1, and liftoff of Space Shuttle Columbia.
6 minutes into her 24th flight, the old gray lady of the Space Shuttle fleet showed she is spry as ever. Traveling at 13 times the speed of sound, Columbia rolled 180 degrees.
Columbia, single engine press, 104, nice roll.
The fancy flying pointed the shuttle antennas toward tracking satellites sooner. NASA is planning to close a ground station in Bermuda, which has tracked shuttles in the past.
Go at throttle.
We're not one of the more glamorous missions, but there are no unimportant missions in this program.
Perhaps the most glamorous moment of the mission will come 5 days after launch. A basketball-sized, free-floating camera will hover around crew members Winston Scott and Takeo Doi during a spacewalk. The camera is a prototype for the International Space Station. Designers are looking for a safer, cheaper way to inspect an orbiting outpost.
And I may go so far as to add that if we had something like this aboard the Mir right now, it would certainly aid in inspecting the Mir for whatever external damage they might, it might have incurred.
The 6-member crew is scheduled to spend 16 days in space. The crew may best be remembered for its multinational flavor. On board Columbia, a Ukrainian, a Japanese, and a native of India. So how will the crew celebrate the U.S. holiday of Thanksgiving?
Well, we'll probably have a little international flavor to it, but we're bringing our turkey on board. It is, after all, an American vehicle.
For NASA, 1997 has been anything but a turkey. This is the 8th shuttle flight of the year, a feat the agency hasn't accomplished since 1992. Miles O'Brien, CNN, reporting.
The Disaster Assistance and Rescue Team at NASA's Ames Research Center is evaluating a new rescue tool.
You okay? Are you okay?
It's a blanket made from recycled plastic milk bottles. Ordinary blankets used at disaster scenes are usually made of wool or fleece. The so-called milk bottle blankets are superior in many ways.
It's lightweight, it dries faster than wool, and it's got roughly the same insulation value as wool or fleece. It dries a little bit faster than fleece also.
The key is the blanket's honeycomb design.
We start with a flat piece of material, produce many cuts in it, and expand the material, stretch it out. The end result is that we have a lot of small air pockets caught in there.
The air trapped in these pockets provides good insulation. But the blanket is just the beginning. The same technique can be used with different materials.
For some applications, we want different properties. This is a very soft material, very good for clothing. We've made the honeycomb out of a very crush-resistant material when we wanted more strength and more ability to use it as a spacer between different materials.
White says the milk bottle blanket is a byproduct of NASA's original research goal, better insulation for spacecraft.
Naturally, NASA hopes to benefit directly in the sense of using these materials for spacecraft insulation.
Lighter insulation could help reduce launch costs and improve the performance of spacecraft. As for the milk bottle blanket's future, additional field evaluations by ambulance companies and some Red Cross chapters lie ahead. According to NASA, if all goes well, commercial production may begin within a few years. Lori Waffenschmidt, CNN, reporting.
Life without light may be livable, but it's not much fun if you're a small boy. A rare allergy to ultraviolet light has forced 4-year-old Kyle Richards and 2-year-old Ryan to stay in indoor twilight. Even brief exposure to the sun or a light bulb can bring out blisters. Their mother finally found that her quest for a solution coincided with NASA's own experiment, and last week the boys flew to the United States to be fitted with these suits.
I expected a lot of problems, them putting the suits on, actually keeping the hoods and the goggles on, but they know if they don't, they can't play out, and they've been fine.
It may look simple, but it takes time to don the thermal undersuit with its battery-powered cooling system, and then the loose but tightly woven 2-layer outer suit. Then the face shield and goggles, quickly to avoid the light that's been poison to Kyle for 2 years and Ryan for 1.
Oh, that's a good boy.
The boys got a look at London Tuesday, while Londoners got a look at them. Not a bad bargain for children who find a treat in things any other youngster takes for granted. For Kyle and Ryan, a passenger train is a spaceship, exploring a planet that's been denied to them. In some other sufferers, the condition has gone away in a few years, though it's so rare nobody can say when or if the Richards boys will be free. It would be hard to call this normal life, but for Ryan and Kyle, there's a whole new world out there. Some 2,000 people around the world suffer from the same syndromes, Kyle and Ryan. NASA is looking at the possibility of producing the suits on a large scale.
Ich wollte Ihnen heute einmal zeigen, wie die voraussichtlichen Auswirkungen für das Winterhalbjahr sein werden. Wir haben hier unterschiedliche Farben. Im Westpazifik, an dem Rot zu erkennen, wird es zunehmend trocken werden. Ein Grund ja dafür für die Buschfeuer im Norden Australiens und für die Waldbrände hier in Borneo und Sumatra. Gleichzeitig wird es vor der peruanischen Küste wesentlich feuchter. Auch hier in den Südstaaten der USA ist mit mehr Regen zu rechnen. Gleichzeitig wird es an der Südküste von Alaska wärmer. Ich hatte es gestern schon gesagt, mit noch nicht abschätzbaren Auswirkungen auf die Pflanzen und auf die Tierwelt. Auch wärmer drüben bei Neufundland. Und das alles zusammen bringt dann doch ziemlich starke Veränderungen während des Winterhalbjahrs. Wie sich das El Niño-Phänomen bei uns in Europa auswirken wird, das lässt sich allerdings derzeit noch nicht abschätzen. Ich wünsche Ihnen noch einen schönen Abend.
Mit bis zu 200 Kilometern in der Stunde fegte der Wirbelsturm Pauline über die Pazifikküste bei Acapulco hinweg. Häuser stürzten ein, zahllose Dächer wurden abgedeckt. Nach sintflutartigen Regenfällen hatten sich die Straßen in reißende Flüsse verwandelt. Die meisten der weit über 100 Toten ertranken in diesen Wassermassen. Autos wurden zu Spielbällen der Fluten und Schlammmassen. Mehrere tausend Menschen sind obdachlos. Acapulco, das pulsierende Ferienzentrum, ist ein Katastrophengebiet. Bis zu 10 Meter hohe Wellen brandeten an die bei Touristen so beliebten Strände. Das Strom- und Telefonnetz sowie die Trinkwasserversorgung der Stadt brachen zusammen. Die meisten der großen Hotels müssen nun mit Notstromaggregaten versorgt werden. Der Flughafen Acapulcos ist geschlossen. Ob sich unter den Toten auch ausländische Touristen befinden, steht noch nicht fest. Der Gouverneur des Bundesstaates Guerrero erklärte, noch nie zuvor habe ein Hurrikan in Mexiko derartige Schäden angerichtet. Tropische Wirbelstürme entstehen über den Ozean in Äquatornähe. Feuchtheiße Luft steigt über besonders warmen Meerwasser auf, kondensiert und wächst zu riesigen Luftwirbeln heran, die sich immer weiter ausdehnen. Ein solcher Hurrikan löst sich entweder nach einigen Tagen noch über dem Meer auf oder er trifft auf die Küste und führt zu immensen Zerstörungen. So wie jetzt der Wirbelsturm Pauline, dessen Windgeschwindigkeit in den letzten Stunden etwas zurückgegangen ist und der sich nun nach Nordwesten verlagert.
Gekoppelt werden, die am 29. September die Erdumlaufbahn erreicht hatte.
Die Kosmonauten sind Kommandant Kovalenok links und Flugingenieur Rumin. Vor Fernsehreportern meinten sie, uns geht es gut. Wir beide beginnen das 3. Jahrzehnt des Weltraumzeitalters. Die Sowjets wiesen darauf hin, dass Soyuz 25 heute Morgen von der gleichen Rampe gestartet wurde wie Sputnik 1 vor 20 Jahren. Damals hatte die UdSSR für kurze Zeit einen Vorsprung vor der amerikanischen Raumfahrt. An Bord von Soyuz 25 ist auch eine Kopie der neuen sowjetischen Verfassung, die am Freitag in Kraft trat. Den Start zeigte das Fernsehen der UdSSR mit der sowjetischen Flagge im Bild. Beobachter werten Soyuz 25 vor allem als Beitrag der Raumfahrt zum 60. Jahrestag der Oktoberrevolution, der am 7. November gefeiert wird. Deshalb erwartet man auch, dass die beiden Kosmonauten wenigstens bis zu diesem Tag im Weltraum bleiben.
Um Schiff Soyuz 25 an die Raumfahrtstation Salyut 6 anzukoppeln, sind heute Morgen die beiden Kosmonauten Kovaljonok und Rumin zur Erde zurückgekehrt. Die weiche Landung erfolgte gegen 4:30 Uhr hier in Kasachstan. Mit Blumen wurden die beiden Raumfahrer in Moskau von ihren Frauen empfangen. Soyuz 25 war vor 2 Tagen in den Weltraum geschossen worden. Mit dem Fehlschlag des Experiments scheiterte in diesem Jahr zum 2. Mal ein Versuch der Sowjets, ein Raumschiff an einer Raumstation anzukoppeln. Beobachter hatten erwartet, dass die Kosmonauten bis zum Jahrestag der Oktoberrevolution im All bleiben.
New images released by NASA this week show how fires have spread in Indonesia over the past 2 months. Though many of the fires were started by farmers clearing the rainforest for planting, experts say the flames have spread in part because of the weather phenomenon called El Niño.
Usually it's rainy in Indonesia. Instead, there are fires and drought.
These images, just released by NASA, taken by instruments on a satellite, show how the smoke and haze from these fires have spread in just a month. And because there has been little wind, the smoke isn't clearing out. Meteorologists blame the drought conditions that are fanning the flames on El Nino. During El Nino, the warmer ocean water in the Pacific that triggers rain moves east and misses Indonesia and other parts of the world, while areas normally dry get soaked.
We're already seeing drought going into Indonesia and Australia and the forest fires that are resulting.
Bolivia in South America is blackened by fire. These fires were intentionally set to clear land for crops.
This practice of burning, for indigenous people, it is because they need to sow and eat the produce of their land, and therefore, the simplest and cheapest method they have is fire.
But during this El Nino year, the seasonal rains that normally douse the flames haven't come. Forecasters hope by using these and other satellite images, they'll better understand El Nino and how the ocean waters interact with the atmosphere to create unusual weather conditions not only in the Pacific, but around the world. Scientists say right now the fires are fueled by peat moss, which farmers were clearing to grow rice. Astronomers working with the Hubble Space Telescope gave us a first look this week at the brightest star ever seen. It's the Pistol Star, so called because of a pistol-shaped nebula of gas surrounding it. The gas cloud itself is incredibly huge, nearly 4 light years across. That's equal to the distance from our sun to our nearest stellar neighbor, the star Alpha Centauri. Though Hubble got a great image of it, the Pistol Star is not visible to the eye. It's hidden behind the clouds of the Milky Way.
Well, there's a look at this unique discovery. Let's find out now about its significance. And to help us with that, Jacqueline Mitten of the Royal Astronomical Society is here to take your questions and comments, either by phone, fax, or email, or, of course, live in our chat room. Dr. Mitten, thanks very much for being with us on the show. Let me start by asking, of course, the significance of this Pistol Star. How is it helping us to understand the mysteries of space, so to speak?
Well, we like to know more about stars. We have one star very nearby, the Sun, and we can study that from close by. But one of the things astronomers want to know about is how small can stars get? How big can stars get? So obviously finding one that might possibly hold the record for being the biggest star is a very important discovery.
Now, we're going to try to get our viewers to have a look at the star at some point and get you to explain exactly what's visible there. Why is it called the Pistol Star for a start? I know there's something about the image of it.
Right. The reason it's called the Pistol Star is simply because of that glowing red cloud that you can see around it. I mean, the astronomers that looked at that said, what does this remind us of? And maybe being American astronomers, they thought of a pistol. I'm not sure whether European astronomers would have thought of a pistol, but that's how they saw it. And that's where it got its nickname. So the star at the very middle of that picture is actually blowing off great clouds of itself and causing this nebula, this red stuff you can see there. So they said, well, we'll call the star the Pistol Star.
Of course, we mere mortals hear all these figures. 10 million times more powerful than our sun. It's only 1 million years old. It may burn out in 3 million years. And these are huge figures. How can the sort of average person come to deal with these?
I think it's very difficult. You know, most of us, asked to imagine the difference between 1,000 and 1 million don't do terribly well. So you just have to take it kind of on trust that it's an awful long way away, it's awfully bright, and it's awfully big.
Let me ask you to answer one of our email questions. This one came across the internet from Switzerland, and it asks, is the Hubble Space Telescope being used to search for planets outside our solar system? Will there ever be another type of space-based detector that could study planets more efficiently?
Right. The Hubble telescope actually is not able to pick up planets going around other stars. The problem is that planets are really very small and very dim next door to the stars that they're going around. I mean, if you imagine being out a few thousand, well, even a few light years away from our solar system, and you look back at the sun, you'd find it extraordinarily difficult to pick up the planets of our solar system, and that's what we face. In order to do that, we need much more powerful kinds of telescopes. There are some plans afoot to put huge kind of arrays out in space that might have the resolution that we would need. But meanwhile, people are using completely different techniques to search for planets around other stars.
And let's talk about those techniques. It's interesting because though we're getting all this
excitement about the pistol star right now. In actual fact, it was discovered in the early 90s, and actually by Earth-based telescopes with these infrared cameras. Was there any degree of embarrassment with the top-notch astronomers that, hang on a minute, you know, someone else found this with simpler equipment?
Oh, absolutely not. The whole thing was that having suspected that there was something very interesting here, what the astronomer who did this research wanted to do was get the very best telescope he could to turn on it, and the very best he could do was to get the Hubble with its new infrared instrument on it. So that was able to give him a lot more information than his previous just, you know, peering at it and suspecting there was something very interesting going on. So this is the way that, you know, astronomy progresses.
Well, it's interesting you mentioned the Hubble telescope and the way it's changed. An email from the internet from Pakistan asks, do we really need a hard-to-upgrade and expensive Hubble Space Telescope when the job can be done equally well and at a lower cost from the ground?
That's a question that astronomers are asking themselves. We now have some very large telescopes on the ground. For instance, the two Keck telescopes in Hawaii, which have mirrors that are made of segments, but they're equivalent to being 10 meters across. Now, they are absolutely gigantic compared with the Hubble, which is only 100 inches across. But the real advantage the Hubble has is being up there above the atmosphere. And so far, that's proved to be an incredible advantage. You know, the pictures, say, of the planets Jupiter and Saturn have only been matched by the pictures taken from spacecraft, and it's very clear that even with a relatively small telescope up there above the atmosphere, we're still getting so far the very best kind of results. But I think it's probably only a matter of time before they are matched by the telescopes on the ground.
Well, we'll talk more about the way technology is advancing in a moment. Let's get our first caller on the line. Marcel in Netherlands, your question, please.
Yes, I'd like to know, how is this new pistol star different from an active galactic nucleus?
Right. The question about is it different from an active galactic nucleus?
Give us an idea what that is first.
Right.
Yeah.
Well, there is... our sun belongs to a galaxy we call the Milky Way. And at the very center of the galaxy, the stars are much more tightly packed together than they are out here, where the sun is way on the edge of the galaxy. And probably at the middle of our galaxy, there's probably a black hole. But if we actually look out into space at other galaxies, some of them with black holes at the center are giving out incredible amounts of energy, where gas and stars are simply falling, cascading into a black hole in the center. Now, what we've seen here is not the black hole at the center of our galaxy, and it's not a star that's falling into the black hole. It is simply a single, very, very large star, or at least that's what it's thought to be. There's still a possibility that it could be a little tight collection of several smaller stars.
So we don't
really
even know
don't
that
for
yet.
sure.
Okay.
Yeah.
We're going to try to go to our chat room with a question there. The new technology we have here on Q&A, we can actually go and see what they're saying in real time as this show's going out. On the internet, Ruthie's asking, what do you expect to come out of further space exploration?
Well, that's a very, very big question. Actually, if we knew the answer to that, we probably wouldn't be doing it. I mean, the whole excitement about doing space exploration is not so much answering the questions that you think you know what the answers are going to be. It's finding the unexpected. It's the great unknown. Every time there's a new development in instruments, a new spacecraft goes out to explore the planets, whatever it is, the things that are discovered and the things that are most exciting are the unexpected. And that's why we keep doing it, because, you know, no one can imagine what's out there. And every time we think we know what's out there, nature springs a surprise, though. The universe is just such a fascinating, extraordinary place, and the drive to go out there and explore it and find its wonders is absolutely tremendous.
Well, we're only just getting to start discussing the mysteries of space. Don't go away. We're going to come back in just a moment after this break with more Q&A for Dr. Mitton. But don't forget to join our real-time chat room. You saw there how it works. Once you download the software from our webpage at cnn.com/Q&A, it's easy to join the Q&A talk right on the net. Our chat room opens about 15 minutes before each live show, and I'll be in there too to get things going. Hope you're going to join us for that. We're back in just a moment. Stay tuned. Welcome back to our program. Well, the pictures are spectacular, even if we don't really know what they're showing us, or at least I don't. The Pistol Star is the latest detected by the powerful Hubble Space Telescope. Astronomers say that the brightest star in our galaxy is 10 million times more powerful than our sun. What mysteries might it shed light upon? That's our focus of Q&A this time. Well, let's welcome back Dr. Jacqueline Mitten of the Royal Astronomical Society. Let's get straight to our next caller, Dr. Mitten. We've got Marnie in Sweden with a question. Marnie, go ahead.
Yes, hi. I was wondering if there is any way of detecting if there has been or if there is any type of life form near that galaxy.
Did you say life?
Life form. Any way of detecting life form near that galaxy?
Right. So far, we haven't been able to detect any evidence of life anywhere other than on Earth.
And of course, we should point out, we set our own parameters for what we call life.
That's true, but, well, it's very difficult to know what other parameters we can set. I mean, there are different things one can do. One of them is to look for planets around other stars where there might possibly be the circumstances that could give rise to life. But again, we have to say, maybe we're looking for Earth-like planets because we don't know what other kind of planets would have life. And the other thing we can do is just listen out for what might be intelligible signals that are being given out by radio, perhaps by a civilization somewhere else.
And of course, I gather we're putting out those sort of signals into space anyway, aren't we?
Indeed we are, yes, but if you look back, it's only a few decades and since we've been giving radio and TV broadcasts on Earth. Mm-hmm. Now, those signals are spreading out into space, but they travel at the speed of light. So the greatest distance any of those have got back to is the number of light years that you can count back in time. So say it was something like 1910 or something that the first radio signals were sent out. Well, that gives us 80 light years as the maximum distance that those signals could have got out. But if there's a civilization with a big radio telescope somewhere within 60 to 80 light years of us, maybe they're picking it up. Maybe in a few years' time they will be picking up this CNN broadcast.
So we might have aliens watching CNN. The trouble is, they won't be able to join our lifetime chat room on the web, which...
No, the delay is far too long.
Let me ask you to answer this email question from Germany. It says, do you think it will soon be possible for tourists to spend a weekend in space?
That's quite a serious question, and I'm sure the answer to that on the quite soon is no. It is still a very, very dangerous business going into space. You still need an enormous amount of training. And I really can't see it being a simple tourist matter, not in the foreseeable future.
All the people going into space now aren't quite the sort of fit astronauts, space-age pilots that were trained to go before. It's much simpler people now, if you like, if you can use that expression.
Well, it's been opened up to a lot of people, not perhaps people who are just pilots or the military, but people who are also scientists. But the selection procedure is very, very particular, and you really do have to have a lot of very special qualities. It isn't necessarily age or anything. I know quite recently NASA's oldest serving astronaut, Story Musgrave, who was one of the people who actually serviced the Hubble Space Telescope, retired, and he set the record of being the oldest person to fly in space at the age of 61, and I think that's absolutely great, you know. So age isn't a barrier, but I think you've got to be a really special person. You've got to have the right qualities, the right training, and we're a very, very long way from space tourism.
Right, let's get Carlos in Hungary on the line. Carlos, your question, please.
Yes, my question is what kind of social impact you're looking to get over the studies you're getting over the Milky Way?
Social impact.
Kind of social impact. Well, over the centuries, astronomy has always been a cultural activity as well as a scientific activity. You know, it's part of being human to wonder where we are in the universe. Where do we fit in? Where did our planet come from? What's the meaning of life? And astronomy actually sets out to answer quite a lot of these questions that we have about our own origins. So people often say, is there any point in doing astronomy? Does it have any practical applications? But in many ways, it's like doing music or drama and poetry. It's sort of answering big questions about what it means to be human.
And of course, it certainly gets us talking as well. Listen, don't go away, Dr. Mitten. We're going to do some more Q&A. We have to take another short break. We're back in just a few moments. Don't go away. The chat is just get going. a few minutes left, though, with our guest, Dr. Jacqueline Minton of the Royal Astronomical Society. And I want to ask you, before we get to our caller in New Zealand, just very briefly, what other discoveries do you think are waiting out there? Is there anything really major? Just briefly.
I think some of the things that I'm certainly looking forward to are more things on Mars, because we have the Mars Global Surveyor that's just gone into orbit and is getting into position to do a much more thorough map of Mars. And of course, the Cassini mission has just successfully blasted off towards Saturn, and I know that's a few years to wait, but it's going to be an absolutely great mission. We have a number of other orbiting observatories that are doing great work, the Infrared Space Observatory. You know, there's so much stuff coming in.
There's stuff happening. Mac in New Zealand, your question, please.
Yes. Has anybody thought of searching for a medium other than light or infrared radio waves, etc., by which we can read deep space?
Well, the way we can look at space is through all the kinds of what you might call invisible light, what scientists call electromagnetic radiation, to get technical. I mean, the light that we see with our eyes is actually a very, very narrow band and very narrow view on the universe. And we're now able to explore the universe in actually almost every band. So this includes things like gamma rays, X-rays, ultraviolet light, infrared, radio, absolutely everything. Now, these are all the kind of signals that we can get from every different kind of object in space. There are also particles that come from space, things like cosmic rays, neutrinos, and astronomers are even searching for completely exotic particles that might be out there in space and really very difficult to detect, but might actually account for a substantial part of the mass of the universe, and we just cannot see them so far.
Dr. Minton, we're just going to try the chat room again here. We've got people talking in live time, and Imri's talking here and asking, how long will Hubble stay in orbit? Is it going to fall to Earth like Skylab?
Not yet. There's yet another servicing mission is scheduled, and I guess astronomers will want to keep that going for as long as they can. As long as the great thing about it is that you can actually send up the space shuttle, and you could repair it, and you can add new instruments to it, and it was definitely designed with quite a long lifetime. Undoubtedly, there will come a time when it will be superseded, and there are a group of scientists now who are planning the next space telescope. They want it to be a bigger telescope, they want it to be further out into space, and interestingly, many of them will say, let's concentrate on this infrared part of the spectrum, because this seems to be the most exciting way of looking at the universe
It's
now.
almost like a competition between Earth and space now. Who can see
Yes.
furthest? Let's get Ken on the line from Germany. Your question, please.
Well, just to put it in perspective, say theoretically, if this star were to be in our solar system, would it encompass, say, like Venus's orbit or Earth's orbit or Mars' orbit? I mean, how large is it really?
The scientists who've done this work say that it would be large enough to encompass Earth's orbit. It's that big.
Which I think was about 200 times the size of our sun. Is that how it worked out?
That would require a quick sum, but I know it's bigger than the Earth's orbit, yes.
But of course, this crucial thing, it being 10 million times more powerful, that's the strange thing.
Well, it's not that unusual in a sense, and in fact, although this star is being billed as one of the most luminous in our galaxy, there are other contenders. There's a star that can be seen from the southern hemisphere, from people who are watching in Australia and New Zealand, a star called Eta Carinae, which during the middle of the last century became the second brightest star in the sky. And until the Pistol star was discovered, that was usually quoted as being probably the most luminous and large star. So there are other contenders out there.
Now, when we had that question about what's being done, what's being looked at, and which methods, you were mentioning the new telescopes in space and so on. Do astronomers actually go with specific targets, or is there an element of let's point and shoot and see what comes up? How much is it balanced between the two?
Well, the way it works is that the telescopes are up there, and then astronomers compete to have observing time on those telescopes. So there are panels of people who receive all the
with a goal.
all the requests from astronomers who say, I think if we looked at this, we might make a great discovery. And a lot of it is based on, yes, we've had a look with a ground-based telescope, we've had a quick look. if we were to turn this really much more powerful telescope, then we would be able to find out a lot more detail and answer more questions. But another thing that orbiting telescopes do, particularly the ones that are looking in the infrared, ultraviolet, X-ray, whatever, is to do surveys. That is to scan the whole sky and look for things that we simply do not know are there from the ground. And then you can identify these objects and say, let's take a closer look. And sometimes this leads to discoveries of whole new classes of objects, kind of things that we simply didn't know existed before.
Now, Dr. Minton, just as we're leaving, just tell me, do you think we're going to see more of this pistol star? Is this really the thing of the moment?
Well, to be honest, I think the research will go on that particular star, but I think that more importantly will be to spend time looking at many more different objects so we can get a much bigger picture of what's in our what's in the galaxy and what's in the universe.
A piece in the jigsaw, and we'll keep working.
Indeed.
All right. Dr. Jacqueline Minton, I want to thank you very much for being on Q&A with us today and taking our questions. Thanks. All right, and thanks to you, our viewers, for taking part. Before we go, I want to remind you that updates on Q&A shows are available on the World Wide Web. Again, the website is cnn.com/Q&A. You can email us from that page. You can leave messages on our message board. You can even download that software for our chat room, which you saw today on the show. That opens during the live show. And that's it for now, though. Thanks for joining the program. We hope to see you next time.
Mourning the death of U.S. singer and songwriter John Denver. He was killed Sunday when his experimental plane crashed into Monterey Bay, California. Denver had millions of fans worldwide. He was 53.
Shortly after takeoff from Monterey Airport in California, he recorded numerous hits including Annie's Song, Take Me Home Country Road and Rocky Mountain High. US President Bill Clinton paid tribute to the singer, saying his music touched millions. He also praised him as a dedicated champion of the environment.
Take me home to the place I belong.
Die Landstraße, die nach Hause führt, das kommt einem bekannt vor. Vielleicht aus dem Radio, damals in den 70ern, vielleicht vom Lagerfeuer im Campingurlaub, wo seine Musik Menschen zusammenbrachte. Und nun endet sein Weg hier, in der Bucht von Monterey. Am Sonntagabend war John Denver mit seinem Flugzeug gestartet, allein, ein Mann, der das Fliegen liebt, klare Sicht, kaum Wind, ideale Bedingungen für einen kleinen Ausflug über Lovers Point. Wir haben es gesehen, erzählt Carolyn Pearl. Auf einmal gab es einen gedämpften Knall, dann ging das Flugzeug hoch und dann runter, senkrecht, geradewegs ins Wasser, hinter den Felsen. Warum konnte John Denver das Flugzeug nicht abfangen? Er gilt als guter, manchmal aber etwas draufgängerischer Pilot. Die Erinnerung an eines seiner Lieder mischt sich für seine Freunde in die Tragik. Irgendwie passt es. Er tat das, was er liebte, er flog und sein allererster Song war Leaving on a Jet Plane. Und nun stirbt er in einem Flugzeug. Ein wenig ironisch ist das schon. Amerikas Troubadour. In seinen Balladen verschmolzen Country- und Popmusik. 1943 geboren, mit deutschen Vorfahren. Sein richtiger Name war Henry John Deutschendorf. Er lebte in den Rocky Mountains. Seine Liebe zur Natur beschrieb er in seinen Liedern. John Denver war dabei ein politischer Mensch. Er engagierte sich im Kampf gegen den Hunger in der Welt und für den Umweltschutz. Vielleicht begann hier auch sein Traum vom Fliegen. Der Sänger bewarb sich sogar einmal für einen Flug zur russischen Weltraumstation Mir. Seine Songs waren wie er. Geradlinig, einfach und ein bisschen schmalzig. Sie verkauften sich millionenfach, weil die Menschen seine Musik mitsingen und mitfühlen konnten. Vielleicht deshalb, spielte John Denver in Vietnam. Er machte gewissermaßen die Vorhut als erster amerikanischer Sänger seit dem Krieg, 2 Jahre vor der Wiederaufnahme der diplomatischen Beziehungen. Das Schönste ist, so hat er einmal gesagt, dass meine Musik Menschen zusammenbringt. John Denver wurde 53 Jahre alt.
Rocky Mountain High. Rocky Mountain High.
NASA's Jet Propulsion Lab in California features global images of just how El Nino developed this year, starting in March. It's an El Nino watch from space, courtesy of a U.S.-French satellite. The white and red areas are warm ocean waters growing larger along the equator.
With the, the clicking features is you can go to the stuff that's just pretty and exciting, or you can really get to the buried deep, real meaty science part, all on the same page.
The JPL page also features links to other El Nino sites, and for a look at the El Nino forecast and some of its likely effects, click over to the site run by NOAA, the National Oceanic and Atmospheric Administration. The main feature of the NOAA pages, an animated graphic that clearly shows El Nino's changes over the last 6 months. This picture is updated weekly to show the latest sea surface temperature.
For example, if you wanted to look at the influence of El Nino on climate extremes over the United States, there's information on that. There's also information on how El Nino affects global temperature and precipitation.
Now from government sites to the grassroots. Weather fans and storm chasers devote part of this site to El Nino.
Basically, I have a summary of what El Nino is in plain language, so it's not really hard to understand. It's not really technical.
There are plenty of other El Nino sites on the web, including this one from CNN Interactive at cnn.com/El Nino. Dick Wilson, CNN, Atlanta.
Hello, I'm Jim Clancy. Welcome to this special edition of Insight. Breaking the Barrier, 50 years of supersonic flight. On October the 14th, 1947, a young Air Force captain named Chuck Yeager streaked across the sky in a top-secret aircraft built with just one mission in mind, to break the sound barrier. 11 kilometers below, the first sonic boom ever created by a human pilot rolled across the California desert, and the supersonic age had arrived. We're going to be talking with Chuck Yeager a little later in this program, and we'll also hear from a noted aviation expert about the impact General Yeager's feat has had on the aerospace world. But first, let's find out a little bit more about the sound barrier and the very real perils it posed for aircraft designers and pilots alike. Today, of course, we take supersonic flight for granted. But 50 years ago, many leading scientists were convinced of just two things. One, the sound barrier would never be broken. And two, many brave pilots would die trying. In 1947, just weeks before Yeager's record-breaking flight, the U.S. Army Air Corps became the U.S. Air Force. Its creation as a separate service came in recognition of the part air power had played in World War II. In Europe, Allied bombers pounded the Third Reich into submission. On the other side of the world, an atom bomb carried by a single B-29 ended America's war with Japan. The next war, everyone knew, would be atomic. America had the bomb and the U.S. Air Force had the bombers to carry it. The new service was flying high, but there were clouds on the horizon. American B-17 flying fortresses had taken a terrible pounding at the hands of German interceptors and anti-aircraft fire. But in the Pacific theater, the new B-29 superfortresses flew up and away from their Japanese pursuers. Higher and faster. That was the mantra Air Force brass repeated after the war. The new jets promised performance far beyond that offered by any propeller-driven planes. Pilots of the hottest wartime prop planes could reach speeds of about 640 kilometers per hour in level flight. In screaming power dives, they approached the sound barrier and returned with tales of planes nearly shaking apart, total loss of control, and other aerodynamic demons that lurked near the speed of sound. Some never returned at all. The theory behind the sound barrier has been known for more than a century.
In 1887, 60 years before Yeager's flight, an Austrian physicist, Ernst Mach, calculated the speed of sound at sea level, about 1,225 kilometers an hour. In his honor, supersonic speed has always been measured in Mach numbers, with the sound barrier placed at Mach 1. But theory was one thing, facts another. In 1947, even the most advanced wind tunnels could not simulate supersonic speeds. The only object that scientists knew for certain could break the sound barrier was a bullet. And so that is what they designed. The Bell X-1 was built in the shape of a giant 45 caliber bullet, supported by the thinnest wings ever built. But what would it take to propel the plane beyond Mach 1? Physics prevented piston-driven aircraft from reaching supersonic flight. Jets were certainly able to in theory, but it would be years before technology made that possible. So, to power the X-1, designers turned to rockets. Because of their deafening shriek, the aircraft's 4 black metal rockets were dubbed the Belching Black Bastards, although for publicity reasons, the nickname was changed to the more acceptable Black Betty. So the plane was ready, the power system was ready, and all that was needed, someone to fly it. Bell test pilot Jack Willems told everyone he was going to be the first man to break the sound barrier. But after conducting the first X-1 flights, Willems was killed while test flying an experimental racing plane. Another civilian test pilot, Slick Goodland, was hired to take over the X-1 program. As promised, Goodland took the plane up to the edge of the sound barrier. But then he demanded a bonus of $150,000 before attempting to push beyond Mach 1. Tired of the delays caused by the contract negotiations, the Air Force decided to hand over the controls of the X-1 to one of its own pilots, a 24-year-old World War II ace named Chuck Yeager.
Some say Yeager did more than just push the envelope. He pulled the whole post office into the next century. We'll hear from the man with the rightest stuff of all right after this. Picture this. It is 10:26 a.m. Tuesday, October 14th, 1947. You are 8 kilometers above the California desert, shackled to a giant B-29 mothership. Behind you is enough rocket fuel to blow you into pieces so small no one would ever be able to say for certain how you died. In front of you, the canopy covered with shampoo to keep it from frosting over in the thin blue sky at altitude. Beneath you, a parachute whose only real value is to provide something soft to sit on. That's because on the right, the only way out of the aircraft opens onto the leading edge of the razor-sharp wing. You are still sore from a horseback riding accident a few days ago that left you with a couple of cracked ribs. You are cold, even in your leather flight jacket, and cramped inside a cockpit 2 sizes too small. You are about to attempt a feat that has confounded and killed some of the world's bravest and most skillful pilots. Are you afraid? You're Chuck Yeager. No sweat. My colleague Charles Feldman, himself an avid aviator, caught up with Yeager recently at Edwards Air Force Base in the California desert.
A lot of people would think, considering your background, that you, when you were a kid, thought nothing but wanting to climb into an airplane and go flying. But I understand that that's not the case. You really didn't want to be a pilot, did you?
I never saw an airplane on the ground until I enlisted in the Army Air Corps in 1941, September 1941, because I was raised in West Virginia, and you're in the mountains, there's no airfields and no airplanes. You saw one fly over once in a while, but they didn't mean anything to me. And then even then, when I got into the Air Force, it kind of a funny thing happened. I was made crew chief on AT-11s. I changed the engines on my airplane in January '42, and here's still, I'd never been in an airplane.
Had it all to this time.
And had no idea what the hell flying was about. And my engineering officer, when I changed the engine, said, how about going, flying with me? So I'm going to test out your engine. And so I got in the airplane. After about 30 minutes, I puked all over my airplane. I said to myself, man, you've made a big mistake.
I was going to
answer that's the way it happened. My first ride, I got sick as a dog, and it was just you know, I didn't ride anymore until August 42. I was called up for pilot training, and then I was sent to primary in PT-21s, and the second flight I made, I got a little woozy, but then I started flying the airplane, and it didn't make any difference. I overcame it.
How is it that somebody who really didn't have any, as a child, great love affair with flying or airplanes, why did you elect to enlist in the Army Air Corps to begin with then?
Well, the Army Air Corps recruiter was better than the Navy recruiter. When I got my wings in March of 10th, 1943, I was made a flight officer. After 6 months of intensive training of dogfighting, air-to-ground gunnery, air-to-air gunnery, dive bombing, skip bombing, and all this stuff, we went to England with the first Mustangs in 8th Air Force, and I was into combat against the Germans. And I remember March 4th, 1944, on my 8th mission, I shot down ME-109 right over the middle of Berlin with the Mustang. Next day, I got shot down and evaded, and the Germans never caught me. And I got the underground, went through the Pyrenees, and went to Spain, was interned, and then to Gibraltar, and the British flew me back to England.
But are the qualities of a fighter pilot different than the qualities for a good test pilot?
I take a good fighter pilot, and I train him in a test arena, teach him how to be a test pilot, do test work. Now, who made the best test pilot? You go back, combat pilots. And the reason was that the guys who had flown combat were disciplined, you know, to death, you might say. And in the test world, it's a hazardous game.
How did they define the mission of the X-1 for you?
The X-1 is very simple. Break Mach 1.
That was it?
As soon as possible. Get the airplane above the speed of sound. And see, we had never flown an airplane much above 82% of the speed of sound up till this point. Everything was unknown.
What did they think? I mean, in those days, right, there were a lot of concerns about what might happen if an airplane got past the sound barrier, wasn't it?
Well, probably 50% of the aerodynamists didn't give us any chance at all of succeeding.
The people who were in the 50% who thought that you weren't going to come back from that, what did they think was going to happen?
The airplane would disintegrate or break up or something. So but I never gave it any thought, really.
Yeah, but you had half the people saying you're going to break up, half the people saying you're going to be fine. You had to think about it.
No, that's not
at
your,
all.
No, it's not your job. The old man said, go do it.
Right. No concerns, no worry, no fear.
There's a real phrase, Charlie. Yours is not to question why, yours is to do or die. But there's on.
But you know fear, don't you?
Well, no. That's why I explained why we were disciplined in combat to be able to step into the research arena and you were so disciplined, you didn't let your feelings affect your actions.
Do you remember the first time you saw the plane, the X-1?
Yeah, we went up to Buffalo and watched them run the engines, and man, it was horrible noise, but it was a beautiful airplane, very simple, basic, but it was very strong, built for 18 Gs, positive or negative. But also, there were a lot of things on it that were very dangerous, you know, liquid oxygen and pressurizing. The airplane was not designed to land or take off with a full fuel load. It was always launch, and you had to get rid of that fuel to land, number one. Number two, you had no way getting out of the airplane. Once you were in it, that's it. And so consequently, I looked at it, you know, it's a matter of developing faith in the damn thing and having a feel for that it wouldn't bite me without giving me some warning.
But some people would say, gee, you know, if you're a test pilot, to climb into something where there's no designed exit is foolish.
Hey, that's where it was in those days. There were no ejection seats, and that's the way it was.
Didn't bother you?
No. I didn't know any difference anyways. We knew the airplane, and on October the 14th, 47, we didn't plan to go Mach 1. We didn't even know if we could, for Christ's sake. All I was doing is that every flight I made was increasing the Mach number. And on that particular day, I was sitting there looking at the Mach meter. I got it up to about 9.6, and we were in buffeting. And the Mach meter needle fluctuated and went off the scale. The gauge only went to 1.0, I don't think they had a lot of confidence in us, but it was, the needle fluctuated off scale, and when it did, all the buffeting smoothed out because we had supersonic flow of the whole airplane, and we made the first sonic boom here at Muroc by an airplane, and kept it out at about 107 for 20 seconds, and raked the rockets off, and decelerated, and came it on down and landed, and that's exactly the way it happened.
You make it sound a bit as it almost was anticlimactic. You must have felt something when
sure, I can go back and say, you know, I was surprised that it turned out so easy, and was disappointed that the airplane didn't blow up. You know, so but that's exaggerating. But the point is, I was at the right place at the right time, and was successful. Yeah, I could have busted my tail too, or somebody else could have been in the cockpit.
Chuck Yeager, an American icon. And what of that other icon, the Bell X-1, named after Yeager's wife? Glamorous Glynis occupies a place of honor at the National Air and Space Museum in Washington. But where will the plane, and its pilot for that matter, be placed in aerospace history? We're going to put those questions to a renowned aviation expert right after this. Welcome back to our special look at the 50th anniversary of the breaking of the sound barrier. World War II began, of course, with prop-driven biplanes. It ended with swept-wing jets. With such dizzying progress, post-war aircraft designers believed the sky was the limit, and many were even looking beyond to the stars. Then they ran smack into the sound barrier.
Got everything you need?
Yes, sir. We got you all strapped in.
If the speed of sound were the aerospace equivalent of the New World, Chuck Yeager was its Columbus, and Glamorous Glynis his Santa Maria. Yeager, as we have seen, is still flying high at the age of 74, and so is his Bell X-1A. The plane that burst through the sound barrier now prowls a much smaller patch of sky, about 20 meters above the heads of visitors to the National Air and Space Museum in Washington. Don Lopez is the museum's deputy director. He's also an aerospace historian and writer, a longtime friend of General Yeager's, and a quite well-known aviator in his own right. He says the record-breaking X-1 is one of the museum's most popular attractions, even if its pilot's reaction to the feat remains decidedly low-key.
He realized how important it was, and he described last night, he gave a lecture here last night in some detail about how important the discoveries they made on breaking the sound barrier, mainly to do with controlling the airplane at those speeds, that gave the U.S. an advantage in combat for quite a few years, all through the Korean War. They put the flying tail on the airplane, in which the whole horizontal stabilizer moves instead of just the elevators at the back. And no other country had that till some 5 or 6 years after that.
The museum is home to just about every landmark aircraft in aviation history. The Wright Flyer is here, so too the Spirit of St. Louis, and the Apollo 11 command module that carried the first astronauts to land on the moon. Curiously, they were all built and flown by Americans. Is there something in the national psyche that makes Americans look to the sky for challenges? Lopez says yes.
Well, it's almost a religion in this country. We started it with the Wright airplane. Actually, the French sort of took it over before World War I. We didn't have any American planes, designed planes in the war. We've had some manufactured ones, British designs. But after that, we got with it a little better and have done quite a few of the major breakthroughs in aviation after that, and we certainly lead the world now.
So what challenges are left for aviators?
I don't know of any aircraft records that are about to be broken, or anybody's particularly interested in anything to break. The Voyager flight, nonstop, unrefueled around the world, they called that the last first. The main record people are shooting for now is to go nonstop around the world in a balloon.
How about breaking the sound barrier on land? 50 years after Yeager did it in an airplane, a British racing team finally went supersonic on land. The jet-powered thrust SSC vehicle roared to nearly 1,330 kilometers per hour over the Nevada desert. Why did it take so long to break the sound barrier on land?
It's hard to control those cars at those tremendous speeds on the ground. If you turn the wheel, you know, probably a half an inch, you'd probably roll it over. And there's a lot more drag. You've got the drag, the aerodynamic drag, which you would have, plus the drag of the wheels on the ground.
The Pentagon kept Yeager's record-breaking flight quiet for months afterward in order to keep military secrets from falling into the hands of their Cold War adversaries. It makes you wonder what's flying up there now that we're not being told about. What about this aircraft called Aurora, which either zooms around the edge of the atmosphere at Mach 6 or doesn't exist, depending upon whom you want to believe? Lopez says he doesn't know, and he isn't telling.
I just read the same thing you probably read. I've read a lot of things thinking that it exists, but I don't know anything official. But I'm not cleared for any classified material anymore than that. I'm no longer in the Air Force.
Supersonic became the byword after news of Yeager's flight was finally broken. It seemed as if in a matter of years the jet set and the rest of us would be zipping off to Paris at the speed of sound aboard a new fleet of Mach-busting jetliners. So what happened?
It's economic. It's not technical. We could have made a supersonic transport that was better than the Concorde, bigger, a little bit faster, not much. But the costs are so great to develop something like that, and most people can't pay, you know, $7,000 each way to cross the Atlantic, and so there really isn't an economic need for it. And if there were, they'd build them.
Technology, economics, politics, these are the new sound barriers, the new obstacles preventing aviators from taking that next big step. But Don Lopez says it won't stop them for long. When something blocks our path, he says, it's only human nature to fly over it.
It's just a human desire. In all mythology, all the gods could fly. In almost every religion, gods could fly. And it's just been a goal of people forever.
As we end our special report marking the 50th anniversary of the breaking of the sound barrier, we can't help but remember names like Orville and Wilbur Wright, Charles Lindbergh, and of course, Chuck Yeager. And we can't help wondering what will be the next aviation milestone, or who will take that step. Perhaps he or she is watching and wondering along with us right now. That would be nice. I'm Jim Clancy. Happy landings.
Research from the U.S. space program provides more than just technology for use in outer space. What NASA scientists learn is also benefiting cancer patients here on Earth. One example, NASA technology has shown promise in identifying cancerous breast tumors without painful biopsies or invasive surgery. Dr. Muriel Ross directs research at NASA's Biocomputation Center. She joins us from Washington with more on how space science is aiding the fight against breast cancer. Dr. Ross, thanks very much for joining us. First of all, we hear now about virtual cancer detection and virtual surgery. Most of us think of the term virtual when we think of games. Can you explain a little bit about exactly what it means?
Well, virtual environment technology actually has a long history at NASA Ames Research Center. Much of the very early work was done there and not for games. However, the technology did find a great venue in the entertainment arena. We at NASA, though, began to use virtual environment technology to display in 3 dimensions neurons. And then on the basis of that, we were asked by Stanford surgeons to help them to develop a virtual environment surgery workbench, which is just a wonderful idea. We have, during the course of this work, developed very high fidelity 3D images, which the surgeons want. We've been working with craniofacial surgeons dealing with congenital defects in children and with other youngsters who have had skeletal loss from the face due to tumor removal. And so we have these very faithful reconstructions that can be turned around in virtual environment, viewed from any angle. And the surgeons will have tools. We're developing virtual tools so that they can actually go in and practice the surgery before they go in and work on the patient. Dr.
Ross, excuse me, but can I interrupt you just for a moment? you're saying that you can develop these three-dimensional pictures. Can
Yes.
you tell us a little bit about how having, for example, instead of having a regular mammogram, how having a three-dimensional mammogram would make it easier to detect cancer and would then make it easier for the surgeon?
Well, we're really talking about a different kind of approach. The surgeons will use mammograms, and then they will go on from there to do MRI imaging with contrast media and to do sonograms. And what we are doing is working with the surgeons then with the MRI scans, and we reconstruct from those so that we can identify for them the tumor site, its boundaries, and so forth, so that they can know better what to do about that particular tumor in the patient. However, there is other technology, the Hubble Space Telescope chips, for example, that were developed to detect very faint bits of light from distant stars. That technology can also be applied to X-rays, which would be in mammography, for example, where you have these little bright spots that might indicate a tumor that's just beginning, that's extremely small. That kind of technology can be used then to really detect these tiny tumors and to with better result for the woman that get a little tiny lump removed instead of a great big tumor, and that's a big advantage.
And I gather that if the surgeon can see a three-dimensional image of this, they know exactly where to go in and they can cut less, so healing would be quicker?
That's correct. And they also need to have a better understanding of the true boundaries of the tumor, because there are little branches that go out from the main tumor, and you want to be sure that you've got it all, so that with computer technologies you can improve their ability to diagnose these tumors and to really understand their true dimensions, and that's very important. It's also important in trying to determine whether you have a malignant cancer or a benign one, and I'm not saying that morphology alone will help resolve this, but when you have these branching tumors, those are the suspicious kinds.
All right, Dr. Ross, thank you very much for joining us. Bernie?
Thank you.
Coming up on Science and Technology Week, a galactic smash-up. New pictures of two galaxies colliding could be a preview of what lies in store for our galaxy. Hello and welcome. I'm Ann Kellen. Two galaxies crashing into each other in space. Sounds like a science fiction plot, but astronomers were able to get a close-up look at a real collision between two distant galaxies. The Hubble Space Telescope captured some spectacular images that could give us a look into the future of our own galaxy. 60 million light years from Earth, two galaxies crashed into each other. During the collision, each galaxy created a long tail. Astronomers gave them the name antenna galaxies. Scientists have been able to see the collision from telescopes on Earth. And now, images just released from the Hubble Space Telescope show the center of the giant collision where the massive clouds of gas compressed and exploded, creating thousands of new star clusters.
Young stars are very blue, very hot and very blue.
Each bright blue light is a cluster of stars.
And we estimate that in that particular one, there's roughly 1 million stars.
Not only are stars created from the collision, after analyzing several ground-based and Hubble images, scientists now say when two very structured spiral galaxies, like our own Milky Way, collide with each other, instead of total destruction, that merger creates a bigger, less structured galaxy called an elliptical galaxy.
The whole process is really very unusual. When you have two cars collide at high speed on the freeway, you don't get a bigger car, right? But oddly enough, when you have two galaxies collide, it very rapidly settles down to a galaxy that is tranquil enough that its origin is obscure. You can't even be sure that it came out of a collision.
This is one very good guess that astronomers have as to how to make an elliptical galaxy.
Our own spiral galaxy, the Milky Way, is on a collision course with a nearby Andromeda galaxy 5 billion years from now. Based on the new data, scientists speculate what the skies would look like if a head-on collision occurred.
So the Andromeda galaxy is that thing in the upper left. It comes towards us, becomes very large. It becomes warped, gets torn up. All these young star clusters form. Now the two nuclei of the galaxies are starting to come together. And finally, we find ourselves living in an elliptical galaxy.
Our night sky would be clearer and brighter, with no sign of the gauzy Milky Way. Scientists say these new images are helping them understand how this galaxy may have evolved and what its future may be. While the same kind of collision is in the cards for our own galaxy, scientists say there's not much point in worrying about it. By the time it happens, our sun will have burnt out and the Earth will be a lifeless ball of rock. A more immediate threat to the Earth could be ozone loss, and a study out this week gives new cause for concern. Years of measurements over the North Pole have just been analyzed, and they confirm a drop in the atmospheric ozone levels. Rick Lockridge has more.
Ozone is the Earth's sunscreen, and these satellite images show it being stripped away above the Arctic Circle. Scientists say the reds and oranges that signify healthy ozone levels have been giving way to weaker greens and blues every winter for the past 5 years.
And what you see is this big region here, which normally would be high like this, which now appears to have very low ozone. And this appears to be a combination of the winter conditions and the fact that we have quite a lot of chlorine.
Cold winters kill ozone, and the North Pole is not as cold as the South Pole. That may be why ozone losses are worse at the South Pole and have been more widely publicized. But 5 colder-than-average North Pole winters have reduced Arctic ozone levels.
Is there some reason for this, or are we just seeing the vagaries of a randomly fluctuating climate and we've rolled the dice and gotten 4 or 5 long cold winters in a row?
Researchers have been measuring Arctic ozone since 1989, using both high-flying aircraft and satellite readings to calculate the levels of ozone in the stratosphere. Some ozone changes are natural and seasonal. As you see here, ozone levels rose normally over the North Pole from January to June of this year. And Richard Stolarski, for one, is hopeful that the existing international agreement banning chlorine compounds that attack ozone will allow the ozone layer to repair itself.
And assuming that the provisions of that are maintained, we should be seeing the peak in chlorine in the stratosphere and the bottoming out of ozone depletion very soon, and then a very slow recovery over many, many decades.
In the meantime, scientists will be watching this Arctic winter very carefully. Rick Lockridge reporting for CNN.
2, 1, top.
The Ariane 5 rocket thundered into the morning sky over South America on Thursday morning, successfully carrying 3 satellites into orbit. 17 months ago, the first Ariane 5 blew up over the launch pad, destroying $500 million worth of uninsured satellites. To hedge their bets this time, the 13-nation European Space Agency packed the rocket with 2 dummy satellites and a cheap experimental unit. ESA officials hope the newer, larger rocket will help it fill a backlog of launch orders and win billions in new contracts.
A long time ago, in theaters not so far away, millions of Americans discovered an enchanting tale of romance and adventure in the Star Wars movie trilogy. 20 years later, they will find the mythic characters captured in an exhibit at the National Air and Space Museum.
The various costumes from each production, each one has its own drama involved. So it's a very emotional experience to walk through something like this.
There's the towering Chewbacca, Han Solo's loyal sidekick, an inspiration that came from George Lucas's pet dog.
The illustrious Jabba bids you welcome and will...
And the very polite C-3PO. Notice one leg is a different color. It's to give him an experienced look, as if he lost the original leg in an earlier adventure. Remember the Imperial walkers used by the Empire in combat? In real life, they're less than 2 feet tall. To make them seem like they were moving, the models had to be adjusted 30 times for each second of film.
It was all done in stop motion, 1 frame at a time, with people hidden under the set and coming up through trapdoors.
Technology has since revolutionized the movie industry, allowing for all sorts of nifty effects. Now George Lucas is working on a new Star Wars trilogy, a prequel of stories set a generation before the original series.
Now I can have characters who are creatures and things be more flexible in their movements, the way they go around, in their expression, so that it's like I can get better performance out of them. It's easier to direct scenes.
The Force is with you, young Skywalker.
How will Lucas's new film stack up against his originals? Well, sometime in 1999, the public will get to decide whether the Force is still with him. Yoko Altman, CNN, Washington.
The exhibit titled Star Wars, The Magic of Myth will be going on for the next year. The sun is heading into a cycle of increased activity that could cause problems on Earth over the next few years. NASA released images this week of a solar flare that sent a belch of energy toward Earth on Tuesday. While this one didn't cause major problems, solar storms can disrupt satellites and cause power outages on Earth. Another flare 2 days later sent most of its energy away from Earth. The solar activity is expected to increase over the next 2 to 6 years. Meanwhile, scientists say they have solved a long-standing mystery about the sun's surface. Rick Lockridge reports.
New images from the satellite called SOHO reveal a carpet of magnetic disturbances covering the surface of the sun. These just-discovered magnetic fields could solve a mystery that has befuddled scientists for decades.
Namely, why is the outer atmosphere of the sun over 100 times hotter than the surface that we see with our naked eyes?
The corona is the outer atmosphere of the sun. We see it as a ring around the sun during an eclipse, but it's actually there all the time. It is hellishly hot, 3 million degrees, compared to 11,000 degrees further down on the sun's surface. The discovery of tens of thousands of magnetic hotspots churning to the surface in 40-hour cycles could explain why the corona is so hot. Scientists say each one of these spots generates some mind-boggling amount of energy.
It would be as much energy as a large power plant would generate in, for example, 1 million years. So all this energy is continually released all over the surface.
And that energy climbs into the corona, where it is transformed from electromagnetic current into intense heat. Using SOHO, the 2-year-old solar heliospheric observatory, scientists hope to someday get a better fix on when the sun is about to throw a tantrum, spit off a solar flare or prominence, or blow a giant cloud of charged particles toward Earth. Those clouds collide violently with Earth's atmosphere, fouling communications and creating other problems.
It's now widely believed that there's an impact of this on our local climatology.
Now that the mystery of the corona has apparently been solved, there is a new mystery to take its place. What causes the chaotic, ongoing tempest on the surface of the sun? What creates the magnetic fields? What happens to them when the sun enters a period of more intense sunspot activity, a phase it's entering even now? More work for SOHO lies ahead. Rick Lockridge reporting for CNN.
New studies of the universe suggest that Einstein was right. Huge astronomical objects can actually move space itself. Black holes and neutron stars spin so forcefully that they make space swirl around them, according to scientists at MIT. They spotted the phenomenon with a NASA satellite that detects X-rays. And it's just what Einstein's theory of relativity predicted 80 years ago. One of the researchers says it's nice to have proof because so many scientists have based their life's work on that theory.
This is the STS-87 mission, which launched on November 19th. This is myself, Kevin Kriegel, the commander. I'm holding up a cap for my son's soccer team. We're suiting up, getting ready to launch. Pilot Steve Lindsay, a lieutenant colonel in the Air Force on his first mission. Dr. Kalpana Chawla, also a rookie mission specialist on her first mission. My classmate, Navy Captain Winston Scott, on his second mission, getting ready to go. We've got Japanese mission specialist Takao Doi on his first mission, and we have Colonel Leonid Katanyuk from the Ukraine. Leonid is also on his first mission. We're walking down the same ramp as folks have been using since the beginning of the program on a beautiful morning, getting ready to launch at the Kennedy Space Center. We go ahead and get strapped in, and that's myself. We're in the vertical. We normally strap in with the commander going first. It's about 2.5 hours before the launch. The folks in the white suits are also fellow astronauts that are helping us get strapped in and are the last people to check us out, make sure that all our flight data file and all our equipment is in the proper procedure. They
also grow plants and crystals and perform a spacewalk. We plan to bring you that shuttle launch live at the times you can see on your screen. The 6-member international crew plans to perform research experiments during the 16-day mission. A spacewalk is also on tap for the crew's Japanese astronaut. And one of the tests is to involve releasing a solar observatory and retrieving it 2 days later.
Columbia is all set to go, but the weather might not cooperate with the launch. Storms are approaching, and one meteorologist on site described the weather as very iffy. It is a very worldly crew. There is a Japanese and a Ukrainian astronaut on board, and among the 4 American astronauts, one is a woman born in India. During the 16-day mission, the crew will release a solar observatory and take a spacewalk.
The following is CNN's coverage of a live event.
Hello, I'm Jonathan Mann at the CNN Center in Atlanta. We're going live now to Cape Canaveral, Florida, where the U.S. Space Shuttle Columbia is about to take off on a 16-day mission. Its 6 crew members are taking the shuttle on its 24th journey into space to release a solar observatory and retrieve it. 2 days later, they're also to grow plants and crystals and perform a spacewalk. Let's listen in as they prepare for the launch of the shuttle Columbia.
10, 9, 8, 7, 6. Engine start. 5, 3, 2, 1, and liftoff of Space Shuttle Columbia on a mission combining science and the practical aspects of space.
Roger, roll, Columbia.
Houston now controlling. Roll maneuver complete. Columbia now in a heads down wings level position, headed to a 150 nautical mile orbit, inclined 20.5 degrees to either side of the equator. Three engines on board Columbia now throttling back to 67% of rated thrust as the orbiter passes through the area of maximum aerodynamic pressure in the lower part of Earth's atmosphere.
The mission is to last 16 days, but the first experiment is to get underway in just a few minutes from now to test communications gear aboard the shuttle. The shuttle will actually flip over 180 degrees to allow it to get into contact with communications satellites. The new communications technology being tested. In fact, because of a money-saving move, NASA is going to be taking its Bermuda Communications Center offline, and they are testing other ways to keep track of Columbia and other shuttles without the aid of that station. So the shuttle is going to be flipping over in just a few minutes. The first experiment on 16 days of it. There's also going to be a spacewalk, the first one ever, conducted by a Japanese astronaut. A Japanese astronaut, part of an international crew that also includes, for the first time, a Ukrainian and an Indian-born woman. The Shuttle Columbia, beginning 16 days of science and exploration in space.
Booster officer confirms good separation of the solid rocket boosters.
NASA telling us that those 2 flares are the solid rocket boosters that have split apart from Columbia as it makes its way faster and faster into the sky.
2.5 minutes into the flight,
bright lights
performance has been
coming
as
through
expected.
the clouds.
Altitude now
On a
30
Florida
miles,
day that was described as having weather not certainly appropriate for this kind of a launch, but the experts at NASA said it was good enough, and the Shuttle Columbia is now on its way.
In the event of a single engine failure, Columbia could now reach one of the transatlantic landing sites. However, telemetry indicates all 3 engines are continuing to perform well. Altitude now 45 miles, downrange distance 70 miles. 3 good APUs, 3 good fuel cells supporting Columbia's climb to orbit this afternoon.
Its powerful engines only a distant light in a cloudy sky. The U.S. Space Shuttle Columbia now on its way to a 16-day mission in space. I'm Jonathan Mann at the CNN Center in Atlanta. We return you now to regular programming.
This has been a CNN Live event.
Checking some of the stories making news in the United States.
2, 1, and liftoff of Space Shuttle Columbia on a mission combining science and
The Space Shuttle Columbia blasted off from Florida's Kennedy Space Center moments ago, beginning a 16-day scientific mission on board an international crew of 6, including a Ukrainian, a Japanese, and an Indian-born astronaut. Columbia is the oldest of the 4 U.S. shuttles.
Amerikanische Raumfähre Columbia ans All gestartet. An Bord sind 6 Astronauten, darunter erstmals eine Inderin. Im Mittelpunkt der Mission steht das Training für die geplante internationale Raumstation Alpha. Die Crew hat außerdem die Aufgabe, ein Sonnenobservatorium und einen Kleinsatelliten auszusetzen. Es ist die letzte Shuttle-Mission in diesem Jahr.
National crew of the Space Shuttle Columbia heads high above the clouds.
2, 1, and liftoff of Space Shuttle Columbia on a mission combining science and the practical aspects of space.
Less than 2 hours ago, it was ready, set, liftoff as the Space Shuttle Columbia and its international crew of 6 blasted into orbit from Kennedy Space Center in Florida. The astronauts wasted no time getting down to business. They successfully completed their first experiment just 6 minutes into the flight. A 180-degree roll during the 16-day mission. The crew is to release and retrieve a solar observatory and to conduct a spacewalk.
Here we've moved ahead just a couple of hours, and we're just a few minutes before launch now. During the last few seconds, the computers take over, and if everything goes along okay, we're along for the ride. That swing back and forth is what we call the twang. There we're released from the pad, and we are airborne. Passing the top of the tower, we're already going faster than 100 miles per hour. We're rolling to a heads-down position and steering to on course. And here you can see big smiles on our faces because we're all so happy that we're airborne. The ride from Earth to orbit is only about 8.5 minutes. After the first 2 minutes, the solid rocket boosters are done and they are expended. They are parachuted down into the water where our retrieval ships will pick them up and we'll refurbish them and reuse them again. So here you see the solids coming off, and we continue into space on the Space Shuttle main engines. And what you're going to see now is main engine cutoff, at least the results of it, where we're thrown forward in the seats. The external tank is ejected from the orbiter, and that's the residual fuel being vented from the tank as it tumbles back into the atmosphere and into the ocean. Once we're in orbit, the first thing we've got to do is get the payload bay doors open, because that allows us to provide cooling to the orbiter and to the electronic systems. This is not real time. We don't do things quite that rapidly, but if we watch in real time, we spend all day watching the doors open. And here you see a survey of the payload bay with all of the experiments and the cargo that we have inside of the bay.
We did a lot of experiments. We've turned it into a rocket ship, into a laboratory. This is a dendritic experiment. Also, we've got the solar can. It's a SOLSI looking at the ozone layer, and it's opening up, and it'll look at the vertical distribution of the ozone as opposed to other satellites that look down at the horizontal or top-down view. The experiment was the United States Microgravity Lab, and it was the 4th flight of this.
The release was delayed on Thursday while NASA worked on an already orbiting solar observatory, which was having electrical problems. The Spartan mission is designed to have the 2 spacecraft observe the sun's atmosphere simultaneously. The crew is expected to retrieve the satellite in about 2 days.
It's an early morning ritual for these biologists. Heading out in the pre-dawn hours in alligator-infested waters to deposit plastic wire-legged flamingos in Florida's Everglades, an unlikely ally pressed into the service of Everglades science to save real birds. The dawn of a new day begins. From atop observation towers, the biologists check out more than 100 of these phony birds. They hope the decoys will lure authentic birds.
One white ibis and number 3.
It worked. Beauty is in the eye of the beholder. The birds did not consider the notorious plastic garden flamingos tacky and cozied up to them.
What we're trying to do is evaluate the social patterns of these birds.
To encourage the intimacy, phony pink flamingos were painted white to attract threatened wading bird species with white plumage, like snowy egrets, great egrets, and wood storks. No fakes of those birds were used. They cost $27 each, but the price was right for research flamingos, $2 apiece.
4 snowy egrets left number 4, joining the large flock off to the west.
Back around the turn of the century, it's estimated more than 1 million wading birds nested here in the Everglades. Now it's believed there are fewer than 20,000 of them, and their numbers continue to dwindle. But why do they have to use phony flamingos to bring birds to a place that has plenty of food and water? Researchers say that remains a mystery. But the information they're gathering, they say, is helping them put the pieces of that puzzle together.
We're starting to get a picture, I think, of how wading birds make a living in the Everglades. What kinds of things are important to them?
These biologists have learned about water depths and food that could lure wading birds to the Everglades and help them thrive here. So they say it's fair to conclude the plastic flamingos, a fixture on Florida front lawns, are really for the birds. Robert Vito, CNN, near West Palm Beach, Florida.
How about that? And that's all for this American edition. I'm Jim Clancy. Stay tuned. World News from Washington is up next.
Another big important payload was the Spartan satellite, and KC is checking out the Canadian robotic arm. Our intention was to deploy this satellite on the 3rd day and let it go for about 2 days, and it was going to collect data on the solar wind and solar flares, and then we'd come back and retrieve it. So here we are unberthing the Spartan satellite, doing our last-minute checkouts, and then we'll go ahead and release it. We're waiting for it to do a pirouette maneuver, and then we'll back away and let it fulfill its 2-day mission. Unfortunately, everything doesn't always go as planned, and as we were waiting there for the satellite to do its pirouette, nothing happened. So we go ahead and attempt to grapple the satellite and rebirth it and try to see what's wrong with it. You'll see upcoming that in the attempt to rebirth it, the satellite got tipped and had a rotation rate. We were unsuccessful in capturing the satellite. So now we had a 3,000-pound satellite that we were trying to chase, and we chased it for about an hour trying to match the rates and try to retrieve it. Unfortunately, we reached our bingo fuel, or minimum fuel, and was told by Mission Control that we had to back away from the satellite. And at that time, we really thought that a major part of our mission had been unsuccessful.
Die US-Raumfähre Columbia hat vergeblich versucht, den Forschungssatelliten Spartan einzufangen. Er treibt seit 2 Tagen wegen eines Navigationsfehlers steuerlos im All. Jetzt soll der rund 10 Millionen Mark teure Satellit während eines außerplanmäßigen Weltraumspaziergangs eingeholt werden.
Der Versuch, ihn mit einem Greifarm an Bord zu hieven, misslang. Die Astronauten wollen nun versuchen, das 10 Millionen Dollar teure Gerät bei einem Weltraumspaziergang wieder einzufangen.
Der Satellit war nach dem Aussetzen ins Trudeln geraten. Ein Experiment zur Sonnenbeobachtung musste deshalb um 2 Tage verschoben werden. Auch der Versuch, den Satelliten mit einem Greifarm einzufangen, misslang. Jetzt soll er möglicherweise während eines außerplanmäßigen Weltraumspazierganges am Sonntag wieder eingeholt werden.
Die Besatzung der US-Raumfähre Columbia musste gleich zu Beginn ihrer jüngsten Mission einen Fehlschlag einstecken. Der am Freitag ausgesetzte Forschungssatellit Spartan funktionierte nicht so, wie er sollte, teilte die NASA mit. Alle Versuche, den 10 Millionen Dollar teuren Trabanten mit dem Roboterarm der Columbia wieder einzufangen, blieben erfolglos. Spartan sollte insgesamt 1000 Bilder von der Sonne schießen. Nun soll er bei einem Außenbordeinsatz zu Wochenbeginn wieder an Bord der Raumfähre geholt werden. Die Columbia war am Mittwoch zur letzten Shuttle-Mission dieses Jahres gestartet. Sie soll 16 Tage im All bleiben.
Ein Satellit auf Abwägen. Mit einem Greifarm versuchte die indische Columbia-Astronautin Kalpana Chawla hier kurz vor dem Start bislang vergeblich den heute Morgen ausgesetzten Satelliten Spartan wieder einzufangen. Weil dessen Navigationssystem defekt ist, kreiselt Spartan im All herum. Nun soll das 10 Millionen Mark teure Observatorium bei einem Weltraumspaziergang am Montag eingeholt werden. Spartan soll die Eruptionen und Winde an der Oberfläche der Sonne beobachten.
Bei der Mission der US-Raumfähre Columbia ist das Navigationssystem eines Forschungssatelliten ausgefallen. Der zur Sonnenbeobachtung ausgesetzte Satellit trudelt jetzt ziellos umher. Der Versuch, ihn mit einem Greifarm an Bord zu hieven, misslang. 2 Astronauten sollen den Satelliten nun auf einem Weltraumspaziergang wieder einfangen.
Two of the astronauts will try to retrieve by hand NASA's $10 million Spartan satellite, which began spinning out of control last Friday. NASA says the spacewalk may include a 90-minute wait before the satellite is within grabbing range. The rescue effort marks the first time in 5 years that NASA has been forced to retrieve a satellite by hand.
The folks down at the ground came up with a great plan to retrieve the satellite manually. And here you can see I've got my little satellite simulator thinking of how we're going to capture this thing if we come up to it and it's still rotating.
And here you see Takao Doi and myself, Winston Scott, inside of the airlock. We're checking out our suits, getting ready for the first EVA. Now we've jumped ahead several hours, obviously, because Takao and I are perched on foot restraints inside of the payload bay. Kevin and Steve have piloted the orbiter up to within arm's reach of the satellite. And what we're doing is just observing it now. We're watching for its motion, for its speed, for its direction, for the modes, getting ready to make the capture. Now, I have to remind everybody here that because everything looks so slowly, it doesn't mean that it is. We're still moving around the Earth at 17,500 miles per hour with a 3,000-pound satellite above our heads. The next scene you're going to see is where we actually reach up and grapple and grab the satellite, and there we are. And you can see that we're rotating it forward so that we can get it to the proper orientation that will allow us to berth the satellite into the payload bay. And there we are. We're moving the satellite down into the locking guides so that we can lock it down and bring it back home again. Now, once we berthed the satellite, that was not the end of our EVA. As a matter of fact, we continue with a nominal timeline. Here you see me with the red stripes, and you see Takao on the left with a pure white suit. That's how you tell the 2 EVA crewmen apart. This device that we're removing from the sidewall carrier is a mock-up of a space station battery. Now, this thing weighs about 550 pounds on Earth, but in space, of course, it's weightless, but you still have 550 pounds worth of mass. Here I'm going to dock this battery to the crane, and now you see Takao testing this space station crane. Now, this crane is to be used on orbit to move large masses around the International Space Station. On Earth, it will not hold its own weight, but in space, it will move hundreds of pounds of mass. It has a manual mode, and you saw Takao using the hand crank just a minute ago. Now he's using a power tool to extend the boom on the crane. The tests during this first spacewalk were marginally satisfactory. I had trouble docking this large battery to the crane, and for that reason, we're going to do a second spacewalk later on where we'll look at other docking techniques. Now, here I'm removing the mass from the crane as Takao pitches it down. We're going to redeposit the mass into its sidewall carrier, and we'll move on with some other experiments. Takao Doi was the first Japanese astronaut to walk in space, and here he's issuing a greeting to all of his people back home. And at the end of 7 hours and 43 minutes, you see me entering the airlock at the end of the EVA. We're going to close the airlock up, repressurize, and go back to our internal activities.
Amerikanischen Raumfähre Columbia haben in der Nacht einen Satelliten gerettet. Etwa eine Stunde lang warteten beide auf einen günstigen Augenblick. Dann packten sie Spartan an einem Teleskopausleger und zogen den $10 Millionen teuren Forschungssatelliten an Bord. Spartan war am Freitag ausgesetzt worden, um Eruptionen auf der Sonne zu beobachten. Er geriet ins Trudeln, weil sein Navigationssystem nicht funktionierte.
2 Astronauten der Raumfähre Columbia haben in der Nacht den Satelliten Spartan wieder eingefangen. Dazu mussten sie aus der Raumfähre aussteigen, während die Columbia den Satelliten ansteuerte. In der Ladebucht warteten sie etwa eine Stunde lang auf den günstigen Augenblick. Dann packten die Astronauten zu und holten den $10 Millionen teuren Satelliten wieder an Bord. Er war vergangenen Freitag außer Kontrolle geraten.
As CNN's Miles O'Brien reports, their mission went off without a hitch.
Astronauts Winston Scott and Takao Doi did not come up empty-handed during their walk in space. As planned, they reached out and grabbed the errant Spartan satellite as Columbia crept close.
Stand by. Stand by.
capture. Okay. Now I've got my end. I got my end. Okay.
NASA ordered up the low-tech retrieval after Friday's botched deployment of the $10 million solar observatory. Spartan did not respond to commands once it was released, and an effort to grab it with the shuttle's robotic arm only made matters worse, nudging it into a slow tumble. After practicing the maneuver underwater and in computer simulators over the weekend, NASA came up with a plan which almost went off without a hitch, literally. Scott and Doy were unable to latch down Spartan by hand, but the robotic arm came to the rescue, grappling, then successfully berthing the satellite. With their Spartan duties complete, Scott and Doy moved on to other tasks, testing tools which may one day be used to build the International Space Station. NASA engineers will now troubleshoot Spartan, and if they can figure out a fix, the satellite could fly again later in this long mission. Miles O'Brien, CNN, reporting.
We also had a joint payload called Q with the Ukrainians and the American scientists, and it was looking at about 10 different experiments on plant growth. This plant that Leonid is getting ready to pollinate is a Brassica rapa. It's kind of the mustard seed family. We're looking at how the effects of microgravity and radiation have on plants and their pollinations, because when we go to space for longer lengths of time, we're probably going to have to grow our own plants and food. And here's Leonid showing a full-grown Brassica rapa. They grow very well in space. Leonid was a great farmer, and he kept busy as a bee. We also talked to students because they were doing very similar experiments while we were in orbit, both in the Ukraine and in the United States. Behind Leonid, you can see the Ukrainian flag, and he was the first Ukrainian to fly on the space shuttle. Every day, we also worked with a mid-deck glove box, and you can see Casey and Steve. We had 3 different experiments. One was the enclosed laminar flame. The other one was the particle engulfment of pushing by solids and liquids, and another was the wetting characteristics of immiscibles. And this are different experiments that we can use in a glove box so it's not contaminating the mid-deck. The flame experiments will help us understand jet engines a little bit better. The particle experiments helps us understand how we can get pure type of materials in space. And the immiscibles is a liquid experiment, seeing how 2 different liquids interface, sort of like if you take oil and vinegar and shook them up, and you'd see how the different materials would solidify or go out into different type of solution.
But a Ukrainian crew member opted for steak. Well, Thanksgiving is America's homegrown holiday.
2 Rakete hat erfolgreich 3 Satelliten im All ausgesetzt. Die Trägerrakete startete vom Raumfahrtzentrum auf der Insel Tanegashima. Einer der Satelliten soll tropische Regenfälle beobachten und genauere Erkenntnisse über das Wetterphänomen El Niño liefern. Außerdem wurden 2 Testsatelliten ausgesetzt, mit denen ferngesteuerte Andockmanöver geprobt werden sollen.
This week, NASA launched a satellite that will study the Earth's rainfall and water cycles. As Rick Lockridge reports, the mission could help scientists understand worldwide climate change, including global warming.
SOB mission liftoff.
The spacecraft is called TRIM, which stands for Tropical Rainfall Measuring Mission. It's a joint project between NASA and the Japanese Space Agency. TRIM's goals are basically twofold: to measure rainfall over tropical and semi-tropical areas, and to better understand how the water cycle, evaporation, condensation, and precipitation of water pumps energy into the atmosphere, fueling the weather patterns that drive storm systems.
So by knowing the total amount of rainfall, we've basically measured how much total water is being condensed in the atmosphere. And so we know how much energy is being put into the atmosphere.
TRIM will orbit the Earth every 90 minutes, using a battery of instruments, including a precipitation radar to monitor rain activity.
The animation you're seeing is really of the TRIM spacecraft coming over and the radar peeling away the infrared image of a hurricane in this particular case to reveal the rain structure within the hurricane itself.
Scientists hope the TRIM data will help them design new and better models that can be used to predict climate change.
Right now, we're terribly concerned with the idea of global change or global warming. And in order to be able to predict that, we need to understand how much energy is being put into the atmosphere, as well as how much energy is being taken out ultimately the atmosphere will warm or cool depending on how much energy goes in or out.
TRIM was designed to operate in an extremely low orbit, just under 250 miles above the Earth. That's good in that the satellite will be down close to the clouds, close enough to get great radar pictures. But that also means the drag of the atmosphere will erode TRIM's orbit quickly. The spacecraft must carry nearly a ton of fuel to periodically reboost itself. At best, the mission can stay aloft 4 years.
When the fuel runs out on the TRIM satellite, we keep a little bit for controlled re-entry into the middle of the Pacific, and that's the end of TRIM.
NASA scientists say they should have their first meaningful results from TRIM in about 6 months. Rick Lockridge reporting for CNN.
Die Rakete Ariane hat 2 Satelliten im All ausgesetzt. Nach einem erfolgreichen Start vom Weltraumbahnhof in Kourou brachte sie den Satelliten Äquator S, der vom deutschen Max-Planck-Institut gebaut worden war, auf die Umlaufbahn. Er soll unter anderem das Magnetfeld der Erde erforschen. Ein japanischer Satellit soll vor allem für Telefonverbindungen in Südostasien genutzt werden.
Here we're preparing for the second spacewalk, and you can see KC helping Takao to don his spacesuit. Takao's on the right side, and I'm on the left side there, and we've got everything on but the helmets now. You can see his communications carry with the microphones down by the mouth. Here you'll see me take a sip out of my drink bag in just a second. If you're going to be outdoors, so to speak, for 6 or 8 hours, you've got to have drinking water, and we carry drink bags inside of our suit. Casey is our internal coordinator, or our IVA, and she's checking the checklist to be sure that we don't miss something before we depressurize that airlock and go outside. Before we started the EVA, we lifted the Spartan satellite out of the bay again, not to release it, but to check out the VGS, or the Video Guidance System. These are laser reflectors, and this system is going to be part of an automatic docking system that can be used on the shuttle or other spacecraft to rendezvous and dock with the space station. Now we're into the spacewalk again. You can see Takao on top, and I'm on the bottom, and we're setting the crane up this second time around. And as I mentioned earlier, this time we're going to test docking small masses to the crane grid. Now this small mass here, this spool-looking thing, is just that. It's a cable caddy, or a circular device with cable wound around it. It will be the way that we'll transport electrical cables, data cables, fluid line cables, and so on into space. And you can see I'm having just a little bit of trouble docking that small ORU to the crane. But once I got the technique down, we had several successful dockings and an overall successful test of the crane. Takao is, again, moving the crane, this time with the small mass. He's concerned about the dynamics of the crane, how smoothly it operates, how much it oscillates, and so on. A lot of things to be concerned with a crane like that on orbit. Here, I'm launching a device called the AirCam Sprint, and the Sprint is the basketball-looking flying object you see there on the screen. It's actually a robotically controlled camera system that is flown by a pilot, Steve Lindsay, from inside of the space shuttle. These are pictures that are taken from the taken by the Sprint, and they're beamed back to Earth and back inside of the shuttle. The idea for this device is that if you have a need to survey the outside of your space station or spaceship, you can use this robotically controlled camera to do just that prior to sending people outside. Here again, pictures from the Sprint. Now here's a picture of me, Winston, taken through the eyes of the robot. Steve is flying the camera back into my arms. The control was so precise that I could give him calls such as, you're 6 inches away, okay, you're 5 inches, you're 4 inches. And he was able to guide it directly back into my hands with much precision. Again, I'm standing poised, ready to capture the camera. I'll power it down, and we'll take it back into the airlock, and we'll be done with that experiment.
Zum zweiten Mal haben Astronauten der Columbia die US-Raumfähre verlassen. 5 Stunden lang testeten ein Amerikaner und sein japanischer Kollege Geräte für die geplante internationale Raumstation Alpha. Sie prüften einen Kran und eine ferngesteuerte Roboterkamera. Diese soll die Station genauer überwachen und helfen, die Zahl der riskanten Außenbordeinsätze der Astronauten zu verringern.
Well, we did have to relax a little, and of course we had to eat. You can see I'm laying on the ceiling, or really just gotten myself positioned. Things can get quite crowded, but you can use all different volumes. I'm doing just a little science experiment with pliers to see how it rotates one way, and if I open up the pliers a little bit more, it actually has 2 levels of rotation. We did exercise every day, and here's Steve Lindsay proving that pilots can do exercise and chew gum at the same time. And he's doing the American front roll, and we've got Leonid countering it with the Ukrainian back flip. And we had some tight spaces, but we also try to enjoy ourselves when we're given the time. Nose KC, we spin her up, and using the principle's moment of inertia, she actually slows down when she opens her arms up, just like a skater would on ice. We all slept in different places. This is myself sleeping on the flight deck in our sleeping bag. We had 4 of the folks in sleep stations on the middeck, and Leonid also slept on the middeck on the wall.
A large percentage of our time on orbit is taken up by taking pictures. We take still pictures, moving pictures, you name it, we do it. Here's a video of the Himalayas. And the thing that's so cool about taking pictures from space is that you can see the browns of the deserts, of the dirt. You can see the black tops of the mountains. You can also see the snow and the clouds. And here, the deep blue of the ocean. Now, what you see at the lower right-hand side of the screen is the northwest corner of the African continent. We're actually coming over the Sahara Desert. And you can see just how rich and beautiful those colors really are. It's incredible to watch entire continents go by beneath you in just a matter of minutes.
Let's start off with a perspective, a 3D perspective, starting off in Florida. Can you make this out? That's Florida, and this is the Northeast. Look at all the clouds. Florida has been seeing quite a bit of rain showers. We're going to take a plane ride up and over those clouds across the midsection of the U.S., where it's dry for the most part. Clouds into the southwest, and then off the coast, the west coast. You see the clouds there? Rain is in the forecast for Southern California and Northern California, and lots of it because of that frontal system. Northwest, nothing to speak of into Washington, back towards British Columbia, a little snow there. Let's go over where the real snow is and will be over the next 24 hours. This is this area of low pressure through the upper Midwest towards the interior section of the Northeast. Once this system progresses towards the Northeast, once it starts to collect some of that moisture from the Great Lakes, picks it up, can't hold on to it too long, it's going to drop 1 to several inches of snow here. Frontal system through the southern section of the U.S. is bringing thunderstorm activity into Florida. 1 to 3 inches of rain possible here. Hold on to the umbrella. Snow showers, as I said, in the forecast for the Midwest, and rain showers in the forecast for San Francisco and Southern California. Look at the blue across the map. Very chilly through North Dakota into South Dakota, and then overnight lows. It's going to be even chillier here. 40s along the west coast for highs, and 50s and 60s down through California. 50s and 40s across most of the map. Relatively quiet, though, when the frontal system from the midsection of the U.S. progresses towards the eastern seaboard. No rain here through the southeast, just cooler temperatures. There's the snow flying in the Midwest, yes, and then rain is in the forecast, as I said, with that front.
A storm system building off the California coast, creating heavy surf, promising pelting rains and almost guaranteeing gusty winds, means different things to different species and to different people.
He's like a little homie to me, El Nino. Know what I'm saying? I don't get scared of him. I surf him.
I think will be a great place to come to watch El Nino.
Still, Malibu restaurant executive Steve Herbert isn't taking any chances. Owners of this well-known shoreline eatery hired private contractors to shore up.
We were not really damaged in the 82-83 storm, and the reason why was because of the rock. These are 2-ton rock, and it kept all the debris from damaging the building.
79-year-old Earl Young was concerned enough to go to the nearest fire station and bag sand for his home. This was all the sand left at Fire Station 19 just a few hours after 10 tons had been delivered.
I'm beginning to believe that El Nino is on his way.
Earl's sources try just about every local radio and television station in greater Los Angeles.
Starting Saturday, that's when the nasty part starts. We're looking at anything from gusty winds to even possibly some tornadic activity.
Our top headline story, the first major El Nino enhanced storm could splash 3 inches of rain across Southern California.
Malibu hardware stores saw brisk sales on tarps, storm drains, and rain gear. But one forecaster puts it in perspective.
The idea is that El Nino is a climate phenomenon. It affects an area for an entire winter. And it's not really appropriate to tie any one storm and say that the storm is caused by El Nino.
Nonetheless, with all its publicity, many Californians hope this storm isn't the first of many bearing El Nino's name. Jennifer Arthur, CNN, Malibu, California.
These are jet firings as we get ready to come home. We're getting ready to do our deorbit burn now, and the jets firing through the window. As we intersect the atmosphere, the outside of the vehicle begins to heat up, and that's what that glow was.
Well, when we go subsonic, we make 2 booms over the Kennedy Space Center, and we're showing our contrails. The commander takes control of it. You're looking through our heads-up display. This is what both myself and Steve Lindsay are seeing. We've got airspeed on the left, altitude on the right, and a little diamond is where I'm trying to keep centered up. We'll roll out and see the Kennedy Space Center. We'll be about 6 miles away, 12,000 feet up, and we're pointing down about 20 degrees nose low. Pretty steep approach, and of course we're a glider. We're doing about 300 miles per hour, just sinking like a rock. And there's no go-around capability. We want to make sure we get it right the first time. At 2,000 feet, I'll bring the nose up gently to land in more of an attitude like an airliner, and Steve will go ahead at 300 feet. I'll put the gear down, get ready for the final touchdown. Our aim is to land on those black marks about 2,500 feet down the runway at about 200 miles per hour. We managed to put it down right where we wanted. It was a fairly good touchdown, and it was nice to get back home after spending 16 days in space. Once I have touched down, I'll go ahead and have Steve put out the parachute, and that aids us in our braking capability, so we don't have to heat up the brakes. And then I'll lower the nose, and we'll proceed to slow down. At 60 knots, Steve will go ahead and jettison the parachute, and that's so the drag chute doesn't drape over the engine bells and cause any type of damage. But it's really kind of a mixed feeling. After coming back in space, you're ready to get home and see your family and take a shower and eat some real food, but you also miss the incredible experience it is to work as a crew in space. It takes about 30 to 45 minutes to do all the post-flight landing checks and to get us out of the vehicle. But we go ahead and walk around, and Columbia really was a fine machine. There you see myself on the left doing some of our post-landing checks, and it worked just perfectly for us. There's Steve on the right, and real shortly you'll see the whole crew standing in front of our vehicle after our 16-day mission.
Member crew are back on Earth after a 2-week science mission. During that time, 2 spacewalking astronauts saved a runaway $10 million satellite by catching it with their hands. The daring rescue occurred after the satellite was sent into a spin by another crew member. NASA will conduct an inquiry into the botched satellite release.
Teilweise erfolgreichen Mission ist die US-Raumfähre Columbia heute zur Erde zurückgekehrt. Sie landete planmäßig um 13:20 Uhr mitteleuropäischer Zeit auf dem Weltraumbahnhof Cape Canaveral in Florida. Während des mehr als 2-wöchigen Fluges hatten die 6 Astronauten versucht, den Sonnenbeobachtungssatelliten Spartan im All in Position zu bringen. Sie mussten ihn jedoch wieder einholen, weil er nicht ordnungsgemäß funktionierte.
Es war die letzte Shuttle-Mission dieses Jahres und die NASA kann damit äußerst zufrieden sein.
Die Landung beendete ein insgesamt erfolgreiches Jahr für die amerikanischen Raumgleiter. Einmal mehr konnte die NASA unter Beweis stellen, dass ohne die bewährten US-Shuttles internationale Raumfahrt unmöglich wäre. Rückblick. Vor wenigen Tagen erst testeten die Astronauten einen neuartigen Greifarm in der Ladebucht der Columbia. Die Mission galt als Vorbereitung auf den Bau der internationalen Raumstation Columbus, die ab nächsten Sommer im All installiert werden soll. Auch beim Einfangen eines havarierten Satelliten bewiesen die Shuttle-Astronauten Feingefühl. Für die russische Raumstation Mir stellten die Space Shuttle des Öfteren Rettung in letzter Minute dar. Im Mai lieferten die Amerikaner ein neues Sauerstoffaggregat an die Russen. Den Kosmonauten drohte die Luft auszugehen. Dabei handelten die USA nicht ganz uneigennützig. Immerhin wird die Mir auch von US-Astronauten genutzt. Ein weiteres Highlight in diesem Jahr: die Aussetzung des Hubble Space Teleskops. Im Februar gelang es den Astronauten, das $2 Milliarden Stück zu reparieren und wieder an seine ursprüngliche Position zu bugsieren. Grund zur Freude also bei den Amerikanern. Das Space Shuttle hat sich als Arbeitspferd in der Raumfahrt zweifelsohne etabliert.
This is Shuttle Launch Control at T-minus 3 hours and holding. Our countdown is proceeding without any technical problems, and our activities are on schedule. Final inspection team continuing their activities, which have gone well with no reported problems. And here we are in the crew dining room, where we see the STS-87 mission emblem cake. Mission specialist Winston Scott will be doing the EVA on this flight. Mission specialist Takao Doi also will be doing an EVA on this mission. Our commander Kevin Kriegel for the STS-87 flight. Our payload specialist Leonid Kadynyuk from the Ukraine. Mission specialist Kolpna Chawla, who will be operating the RMS for the Spartan deployment. And finally, our pilot Steve Lindsay, who will be working the sprint camera during the mission, among other things. We are in the suit-up room with our STS-87 astronauts. We're looking at our commander, Kevin Kriegel. And here is pilot Steve Lindsay. He'll be operating from the flight deck the small basketball-sized camera. And mission specialist Kolpna Chawla, who will operate the remote manipulator system and deploy and retrieve the Spartan payload. Mission specialist Takao Doi, who will be participating in the EVA on this mission along with Winston Scott. And next to him here is Winston Scott, who will be also doing the EVA during the flight, along with Takao Doi. And our payload specialist, Leonid Kadynyuk from the Ukraine, who will be investigating plant growth biology in space. This is Shuttle Launch Control at T-minus 2 hours, 56 minutes, 55 seconds and counting, where we see the STS-87 astronauts now are entering the elevator for the ride down 2 floors from the astronaut quarters to the astronaut van, which will transport them the approximately 7-mile distance out to launch pad 39B, a ride which will take approximately 20 minutes or so. And we see some KSC employees behind the chain. The Astrovan now approaching the pad perimeter, where they'll then leave the van and pull up the elevator to the orbiter access arm and meet the closeout crew ready to assist them in boarding Columbia and into their seats. And here we see our Commander Kevin Kriegel preparing to board Columbia. And there Takao Doi is the mission specialist who will be boarding next here very shortly, as soon as Kevin Kriegel boards the orbiter.
Well, this is actually a view from the flight deck, and now he's climbing up into the commander's seat. Keep in mind that everything is in the vertical here. He's getting assistance from another astronaut, astronaut Joe Tanner. Right now he's just positioning himself in the seat. It's very important that they get in the seat straight. They've got some emergency oxygen bottles strapped to their back on the harness, and then they'll be laying on top of the parachute. And they could be in there for upwards of 3+ hours today. And it's very important that he's in a position where nothing is in his back. And there'll be 2 people working on him. There's several connections. Here you see Takao Doi getting into the middeck, and what we try and do here is strap one person at a time in both the flight deck and middeck. So this Takao is MS-3, and he'll be assisted by another strap-in personnel on the middeck. Now once Kevin is strapped in and has his cooling and oxygen hooked up, they'll begin to put on his helmet. And that cord there will be hooked up for his communications. Following his strap-in, they'll do some communications checks just to make sure that everything's in line before they move on to the next crew member. Here's a shot of Leonid in the white room. Looks like he's got his harness on, and he'll be waiting to be the second person on the middeck. There's the pilot, Steve Lindsay, climbing into the flight deck. He'll ask Steve to reach up and grab 2 handholds, and this particular maneuver here is very similar to just doing a pull-up. He's pulling himself up into the seat, getting his feet in position. Joe, you see, is holding on to his emergency oxygen bottles to keep them on each side of the parachute, and then they'll begin the process all over again of getting Steve positioned correctly on the parachute for comfort. Here's a great shot of Leonid. He's in the seat now, the second crew member on the middeck. They'll be hooking up his cooling at this time. This is our first flight of a Ukrainian on the shuttle.
TLS, what is it? TLS, go. Yeah, 534, pick up by the clock. Okay, TLS copies, and we need a CMTC on channel 162, and we need to read step 535 on the OIS.
NTD, MS-1, contact.
MS-1, this is NTD. Good morning, I've got you loud and clear, KC.
Good morning, Doug. I also have you loud and clear.
Attention all stations, this is the NTD performing a launch status check. Verify ready to resume count and go for launch. Say go, no go. OTC. Go. TBC. Tank and boosters will go. CTC. Go. LPS. Go. Houston flight.
Houston flights go.
Myra. Myra's go. SCM. SCM go. Safety console. Safety console go. SCE. SCE go. LRD. LRDs go. SRO. SROs go. You have a range clear to launch. And CDR.
Columbia's a go.
And I copy all. Launch director NTD. Launch team is ready to proceed. Copy that. I'll do a poll. Payload director.
Payload for go.
Engineering director. Engineers go. Safety and mission assurance. Safety and mission assurance is go. Range weather. Roger, sure. No constraints launch. Copy that. Ops manager. MMT is go for launch. Copy that. And Columbia looks like we're ready to go. So we're going to proceed. MTD, you're clear to launch. And have a great mission. TLS is go for orbiter access arm retract.
Lock your visor, initiate O2 flow. Have an international Thanksgiving, and may the roll go your way. Thank you very much.
20.
Firing his chain is now armed.
15.
T-minus 10, 9, 8, 7, 6. Engine start. 5, 3, 2, 1. And liftoff of Space Shuttle Columbia on a mission combining science and the practical aspects of space.
Roll program, Houston. Roger, roll, Columbia.
Houston now controlling. Roll maneuver complete. Columbia now in a heads down wings level position, headed to a 150 nautical mile orbit, incline 20.5 degrees to either side of the equator. Three engines on board Columbia now throttling back to 67% of rated thrust as the orbiter passes through the area of maximum aerodynamic pressure in the lower part of Earth's atmosphere. Three engines now ramping back up to 104%.
Columbia, go at throttle up.
Columbia's 3 liquid fuel engines are now back at full throttle, 104% of rated thrust. Altitude now 11 miles, downrange distance 8 miles. Minute 30 seconds into flight, with more than 2.25 million pounds of propellant having already been consumed, Columbia now weighs half of what it did at liftoff. Standing by for the next major event, which will be the burnout and separation of the twin solid rocket boosters. That coming up in a little more than 2 minutes into the flight. Altitude now 20 miles, downrange distance to KSC 19 miles. Booster officer confirms good separation of the solid rocket boosters.
Columbia, performance is nominal. Low performance.
Commander Kevin Kriegel now rolling a videotape shot from a camera mounted on the forward flight deck of Columbia, looking back aft. On the right side is Commander Kriegel, left side Steve Lindsay in the foreground, flight engineer Winston Scott directly in the middle behind them, and to his right mission specialist Kalpana Chawla. This video of the launch, there's main engine start and liftoff.
I can probably tell by the lights that was the roll to heads up.
Kevin. We were kind of looking for that. We saw it.
It was really pretty smooth.
The crew is planning to work with a number of experiments that are associated with the United States microgravity payload, which is a platform of experiments in the payload bay overseen by NASA's Marshall Space Flight Center in Huntsville, Alabama. Those experiments are mounted on a support structure in the back end of Columbia's payload bay, which is also filled with that Spartan satellite and also the extended duration orbiter pallet of cryogenics. There's a series of experiments. The one on the television now on the downlink from the orbiter is the isothermal dendritic growth experiment, which is an experiment that hopefully may improve manufacturing processes involved in the production of steel, aluminum, and various super alloys that are used in the production of automobiles and airplanes. The investigation is designed to unlock advanced processes that will create some new alloys that may be stronger and may even have better control and more reliable properties than are currently available here on Earth.
Houston, Columbia for Solsi.
And go ahead for Solsi.
Yeah, Mark, just to be sure we're all synced up here, I hold myself to begin DTP startup in about 2 minutes, and we are all set up here to record the door opening.
And we copy, and you can start any time, and we have it on the downlink.
Okay, great.
This is Mission Control Houston. This television from Columbia's cargo bay showing the shuttle ozone limb experiment as the door opens. The instrument will begin its first observations of the mission. It observes the Earth's horizon from orbit and from ultraviolet light reflected off of the Earth's limb or horizon. Gauges the amounts of ozone present in Earth's upper atmosphere. Also underway is an experiment on the lower deck of Columbia in a glove box unit that will be the focus of several different experiments during the flight. In that glove box at present is an experiment called the wetting characteristics of immiscibles. This video is from that glove box experiment. This experiment, again being done in a glove box on the lower deck of Columbia, studies metal alloys and mixing of those metal alloys and wetting effects that are caused as those alloys are melted and mixed, and that can sometimes cause layering as those alloys are created, looking at ways that wetting could be alleviated.
Houston, Columbia, we're going to bring you to the flight deck.
And we're ready.
At the aft flight deck, mission specialist Kultna Chavla will be joined by pilot Steve Lindsay tomorrow for the operation of the shuttle's 50-foot-long robot arm and the deployment of the Spartan satellite, which is scheduled at 3:03 p.m. Central Time tomorrow afternoon. Again, Kriegel is pedaling the bicycle ergometer on the aft flight deck of Columbia, being watched by Leonid Kadenyuk, who has been operating the Q experiment today, the collaborative Ukrainian experiment, which investigates the progress of plant growth in the absence of gravity.
Columbia, Houston, for TGDF deactivation, if you could give us a status on that.
Starting it up right now.
Copy, Steve. Columbia, Houston, the Orbit 4 shift is now trading places with Orbit 2. It's been a great first day for us. We've really enjoyed it. You're off to a great start, and Jeff Bandel is here with his team, and Ellen Ochoa will be talking to you, and look forward to tomorrow working with you on the Spartan deploy.
Thanks, Mark and Bill. I appreciate working with all of you, and we'll see you tomorrow.
This is Mission Control Houston. This live television picture from the end effector camera on the robot arm of Columbia being operated by Kolpna Chawla from the aft flight deck control panel shows the end effector being moved in place for its eventual closure on the grapple fixture on the Spartan Science satellite, which of course, as you see by the sign, is managed by the Goddard Space Flight Center in Greenbelt, Maryland. The end effector now closing in for grapple on the Spartan satellite.
Columbia, Houston, everyone's go for unberth of Spartan as soon as you're in attitude.
Okay, we'll go for our burst once we're in attitude.
Columbia, Houston, you have a go for Spartan release. On time.
Roger. Go for Spartan release. On time.
Columbia at D1 plus 3.5 minutes, and we do not see Spartan doing a pirouette, so at D1 plus 4 we plan to re-grapple.
Columbia, we concur.
tip-off rate. It's rolling around. We'll go ahead and match it and re-grapple.
And we copy.
Yeah, Mark, we're trying the best we can. It's got a pretty good rate on it. We're just trying to match it.
Understand, we know you're working really hard, and we're looking at other possible options, and we'll get back to you. Columbia, Houston, Kevin, for your information, we've got enough prop in the forward RCS, another 5% margin before we're going to have to make a decision about separating. We'll keep you posted on that. When we reach that point, we're going to have to go into a separation, so we'll keep you posted.
Okay, we'll try to get it.
And that would be based on separating and being able to rendezvous subsequently with it to try to get it back. Yes, Kevin, what we're thinking of doing is a little later on today performing a phasing burn. And tomorrow carrying on with our original plan, which is to do the EMU checkout. And the following day, performing a rendezvous with Spartan and an EVA recapture. And we would like you to do a little thinking about it. It's obviously very early in our own thinking, and we'd appreciate any feedback from you, and we'll keep you abreast of any development in this plan.
Okay. Copy all. Thanks, Mark.
Kevin. That's what we're seeing. Great to be with you down in the airlock or up in the airlock.
This is Mission Control Houston. This view shows mission specialists Takao Doi and Winston Scott as they finish up checkouts of their spacesuits that they'll wear on a spacewalk currently planned for Monday. All of that checkout going very well so far. No problems reported by the crew members. Doi and Scott will spend another couple of hours doing EVA preparations, spacewalk preparations, going through the procedures here to restow the gear in the airlock and prepare the airlock for that spacewalk. And also then going through the tools that they'll use and making other preparations to have those in order ready for the spacewalk on Monday. This television from Columbia showing payload specialist Leonid Koteniuk as he works with the collaborative Ukrainian experiment. Koteniuk is a Ukrainian payload specialist flying on board the shuttle, the first Ukrainian to fly on board the space shuttle. The collaborative Ukrainian experiment is a plant growth experiment that studies 10 different plant growth experiments that will operate during Columbia's 16 days in space. In conjunction with the plants and pollination of plants that is being done on board Columbia in the experiment, students are also participating by performing similar experiments on Earth, both in the U.S. and in the Ukraine. The experiment studies the effects of weightlessness on plant growth in general, and specifically on pollination of various plants and weightlessness. These views showing some of the payloads in the cargo bay. These payloads, many of them have been operating throughout the mission, mounted in canisters in Columbia's payload bay. They include various technology experiments studying new technologies that can be used on future spacecraft. Among those are a study of a heat pipe technology that can be used for cooling a passive cooling system that would include no moving parts, being studied for possible use on future satellites. That experiment is called the Loop Heat Pipe Experiment. It's sponsored by the Center for Space Power at Texas A&M University in Corpus Christi, Texas. Also, another experiment in the cargo bay, along with the heat pipe experiment, is called the sodium-sulfur battery experiment, looking at how sodium-sulfur batteries can operate in weightlessness, a possible source of battery power for future spacecraft. Other experiments in the cargo bay that have been operating throughout Columbia's mission include the turbulent gas jet diffusion flames experiment. That experiment seeks to understand the characteristics of turbulent gas jet diffusion flames and weightlessness.
Training session underway, as we see Jerry Ross here, is to evaluate the handling characteristics of the satellite. He and his colleague Jim Newman have been passing the mock-up of the Spartan back and forth to understand and get a good feel for its handling characteristics. The Spartan actually weighs in at about 1,200 pounds. Of course, in space with microgravity, it really has no weight, but its mass is still there, so it is the prudent thing to do to understand the handling characteristics of the Spartan satellite. So they'll continue this training session for another couple of hours in the water tank, which is near the Johnson Space Center here in Houston.
And this wider view it gives a better idea of the size of the satellite in relation to the two astronauts. And again, in this view, Jerry Ross is on the left and Jim Newman is on the right. They are distinguishable by their air hoses, which obviously are not used in space, but underwater they are. And Jerry Ross's is red and Jim Newman's is white.
Scott and Doy in their restraints on the television live from Columbia, showing on the left astronaut Winston Scott, and on the right astronaut Takao Doy. Scott distinguishable by red stripes on his spacesuit. In position for the retrieval of the Spartan satellite. As we continue to watch live television of the Spartan satellite, also in view is the tip of Columbia's mechanical arm. Commander Kevin Kriegel flying Columbia around to position Scott and Doy for the capture of the satellite. Scott and Doy have been spacewalking now for 1 hour and 45 minutes. Columbia is above the Pacific Ocean off the coast of Southeast Asia. Its course will take it south above the Central Pacific.
Are you able to reach the... I can reach it. Okay, let's hold right here. Let's stop right here. Okay. Kevin, if you're ready, we'll do our thing. Okay, I'm free drift. You gotta go. Okay, the cow. Yes. Now, one more time. Can you reach the scope? Yes, I can reach it. Okay. On my signal, I am going to grab a pin and the GPS target. Okay. And as I understand it, you're going to grab the scope. Is that correct? That's correct. Okay, I'm going to give you a standby capture. That's what I will say. Okay? You understand? Yes. Okay. Are you ready? Okay. Standby capture. Okay. Now I've got my end. I got my end. Okay. Now that we've got it, Mr. Doy, yes, let's decide what we're going to do with it. You hold on to your canister. Yes. Let's roll the Spartan right so that it's level in the bay and I can reach my canister. Do you understand? Yes. Okay, let's do that very, very slowly now. We are going to pitch the Spartan down. Okay? Okay? Pitch Spartan down. Okay, let's do that very slowly right now. That's a good rate right there, Mr. Doy. Okay? Looking good. Keep it coming, looking good. Keep it coming. Keep it coming, looking really good. Okay, let's stop right there. Okay, stop. See what we got. I think that looks pretty good. Okay. Now tell you what, we need to let's level it out. Let's just level it. Okay? Okay. Now, let's bring it in my direction, just maybe an inch. Okay? Okay. Let's stop there. Now let's bring it forward about an inch. Now. Let's stop there. Okay, now, can you see your guide? Your guide? I can see it. I can see mine. Okay, let's bring it down into to the top of the guide. Very slowly. I can come my direction. Now these in between two rock backs. Okay, same here. Good. These become my direction, just maybe half an inch. Okay. Now let's bring it on down. And bring it down more. Okay.
Stop. All stop. I think the roll cue we need to give you from inside here.
Go ahead.
And the cow,
yes.
you need to bring your side down so it's a roll.
So how's that?
It's still not level. So the cow looks.
Okay.
And that looks good. And the arm is coming down.
Okay. The boom is now horizontal. I'm pitching up.
Copy the cow.
With us in Mission Control providing insights is astronaut Tammy Jernigan. Tammy, Takao Doi is extending the crane, turning that handle without foot restraint, and from a body position that looks somewhat difficult. Is that on purpose?
Well, one of the things that we hope to evaluate during this crane checkout is various body positions to facilitate operation of the crane, and also to have insight as to where that crane boom is going. That crane boom extends out to over 17 feet, so obviously you have to have good visibility into where the crane's going so you don't bump into anything, but you also have to be able to operate the mechanisms, and right now Takao is trying different body positions to see which is best to operate the crane.
Columbia, Houston for Kevin.
In the foreground you can see the power tool called the pistol grip tool,
That you just read to us.
and Takao has used that to extend the crane. The crane can be extended in a motorized fashion or can be extended manually by rotating a handle. There are 3 handles on the crane. One is to move the crane from side to side or yaw the crane. The other is to move the crane up and down or pitch the crane. And then the third handle is for the manual extension and retraction of the crane.
Your backpack is very close to the Spartan telescope. One counterclockwise.
Okay, 1 counterclockwise.
Alpha 4.
Alpha 4 is set.
Motor.
Motor is set.
At 23.5.
3.5 is set.
You are going to fully...
And Tammy, with the battery now on the end of the arm, they're going to be doing the same evaluations that were done earlier with the arm by itself?
That's correct. They will be, again, maneuvering the crane from side to side and up and down and in and out. Roll and pitch and yaw and extension and retraction with the battery on board. Again, the battery and subcarrier weigh close to 500 pounds, and so you're going to look at the handling characteristics of the crane when it's loaded up as opposed to the handling characteristics when there was nothing on that crane. Having completed most of the operations with the crane loaded with the battery and subcarrier, the crew is now ready to remove that subcarrier from the end of the crane and then rebirth the subcarrier into the guides on the sill. Takao is extending the battery across the payload bay to its stowage location.
Columbia, Houston, we're getting beautiful video of that. That's a real nice view.
Winston, the battery is coming towards you.
Okay. That's release. Okay, Takao, pitch the crane down, please. Okay, continue down the crane. The release position, lock position, lease position, and soft dock position of the subcarrier itself, the actuator, I give it A. All of that mechanism works really nicely. Okay, Steve, would you move me starboard out of the bay, please? Yeah, starboard.
Takao is moving the crane out of the way so that Winston, with the help of the RMS operator, Steve Lindsay, can put the subcarrier and battery into position to berth back into the payload bay.
It's relatively easy to control. Okay. Stop. Stop. And also, Winston, I had to move you up a little bit to make sure your tethers would clear, so that may have been why. Okay, that's great. No problem. Thanks for letting me know. You're on the ramp. Oh. Okay, Kevin, I'm finished. Great, you've had enough fun. I'd put you short away and come back in. Okay. Okay, tethers are configured. I mean, they're inside of the carrier box. They're all latched down, retracted, and yours truly is going to make his exit or make his entry, whichever you look at it.
Okay, Winston, then the call once you get in, check water on.
Okay, calling was all right. And that was successful. I have a successful soft dock. Again, there is compliance in the crane. It moves a little bit, but not very much. I guess maybe 6 or 8 inches before I got soft dock. I'm going to release it and try that same thing one more time. Okay, it's released. It's back in soft dock. I'll do the same thing. Of course, I'm looking underneath the cable caddy at the grid and the dogs to be sure that I line them up before I insert it, but here we go again. And I have soft dock. That was good. I'd give it an A for the small ORU. That was real nice. Okay, would you yaw the crane just a bit more towards me, please? Okay. Yaw the crane towards you. That's good. Thank you. Stop. Okay.
Commander Kevin Kriegel is now flying Columbia. Just under 5,000 feet now. Time to touchdown, 50 seconds. The landing gear is now down and locked. touchdown. And nose gear touchdown. Columbia's rolling out on runway 33 at the Kennedy Space Center, completing a 6.5 million-mile journey that included circling the Earth 252 times. STS-87 is the 12th straight and 19th of the last 20 missions to end with landing at the Kennedy Space Center. The United States microgravity payload mission becomes the 7th longest in shuttle history and the 41st to end at the Kennedy Space Center.
Welcome home, Columbia. Excellent landing, Kevin.